Hello and welcome to Pre-Algebra Lesson 17. And in this video, we're going to talk about integers. Okay, so for our lesson objectives, we want to discover a new set of numbers known as the integers. We want to use the number line to determine the relationship between integers. We also want to learn how to find the opposite of a number. And then lastly, we want to learn to simplify with multiple. And then you see this symbol here. Most of you at this point will know it as a subtraction symbol. Throughout this lesson, we're going to see that symbol used for different things. So I'm just going to put multiple and then show you this on the screen, say symbols. And again, we're going to change the context of that throughout our lesson. All right, so let's begin by talking a little bit about the whole numbers. Now, up to this point, we've only worked with the whole numbers. And typically, these are the numbers you work with in elementary school. We've reviewed how to add whole numbers, and we did that on a number line too. How to subtract whole numbers, again, we did that on a number line. We reviewed how to multiply whole numbers and how to divide whole numbers. And the reason I spent time on that was that if you had forgotten that, when you go to do these operations with integers, you're just going to be behind. So again, the whole numbers start with the number 0 and increase in increments of 1 out indefinitely. So again, remember you'll have these 3 dots here after 3. That just tells you you'd have 4, then 5, then 6. Essentially, that pattern just continues forever. Now, if you look at this illustration here, it's of a number line. And remember, this is just a visual representation of, in this case, it'll be the whole numbers, but in a second, we're going to see that we can draw a visual representation of the integers as well. So look how this is drawn. We have our first notch, or our leftmost notch, occurring where 0 is. And then each notch to the right represents the next whole number, right? An increase of 1. So you got 1, then 2, then 3, then 4, so on and so forth. At some point we stop and we put an arrow there, and the arrow just says that, hey, numbers are going to continue forever, right? And since this is a number line that represents the whole numbers, you can just basically assume that you'd have, 9, then 10, then 11, then 12, then 13, then 14, so on and so forth. So every number that is larger than 0 is known as a positive number. We can place a plus symbol, okay, the plus symbol, or you might know it as the addition operator, in front of a number to indicate that it is positive. We don't typically do this because numbers are by default positive when we work with them, right? That's what we're used to working with. So typically you will not put a plus sign in front of it. So for example, if you have the number 3, you would just write it like that. You know that it's positive. But if you wanted to, you could put the plus symbol in front of it to indicate, hey, this is a positive number. This is a positive number, positive 3. So when we encounter a number that is less than 0, okay, less than 0, we refer to it as a negative number, a negative number. So negative numbers always have and again, I talked about this previously in this lesson, this symbol right here, which we've used for subtraction up to this point. So this symbol, we put that sign in front. So if I wanted to, say, write down the number -3, I would put this symbol directly in front of a 3, and I would have a -3. So this is a negative -3. And again, if I wanted to write +3, I just write the number 3, or I could put a +3 in front of it. In this case, that plus is optional. But when you're writing -3, you have to write it. It's not optional because nobody will know that that's a -3. Again, the default value of a number is going to be that it's positive, right? Because that's what we normally work with. So before we move any further, what exactly is a negative number? So some of you might say, well, I don't know what a negative number is. Well, in most cases, all of you have seen some form of a negative number. You might not have worked with them directly in math, but you've seen a negative number before. One thing or one example that's used in almost every textbook would be a negative temperature. So you're watching the weather on TV or maybe on your phone or something like that, and you find out that tomorrow it's going to be, -5 degrees. Essentially, it's colder than 0, right? It's going to be a lower temperature than 0, and they represent that with a negative value, -5. Another common example would be that you have a negative amount of money in your bank account. So let's say you have $5 in your checking account. You go to the store and you buy $10 worth of groceries, okay? Let's say your bank covers the charge. So you had $5, you spent 10. So you're going to end up with negative $5 in your account, plus probably a fee from your bank saying, hey, you spent more than you had. But that's another example of where we would use a negative value. Kind of a sports one that you could think about. Let's say that you're watching a football game and they hand off the ball, running back runs, and he loses yards. Let's say there's a loss of 4 on the play. Well, if you see them represent that with numbers, they're going to say, hey, that's a play that yielded negative 4 yards. So we have negative numbers around us. We don't use them as often as we do the positive numbers, but they are around us. Now let's talk a little bit about 0. So a lot of people get confused about this. They think that 0 is a positive number. It's not. 0 is special. So it is not positive or negative. It is neither. Later on, you're going to hear that 0 is an even number, but it is not positive and it's not negative. Okay, just think about it as being neutral. Okay, so now let's talk a little bit about the integers. Now the integers are important because from here on out, you're going to work with them a lot. So the integers include the whole numbers and their negative counterparts. So we already know what the whole numbers are. Again, I just put that on the screen at the beginning of the lesson. If you look at the integers here, if you just look at this part where it says 0, then 1, then 2, then 3, then comma, dot, 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 that's the whole number part. Okay, this is the part that we know. Whole numbers. Now what we're just introducing is numbers that are to the left of 0. So you kind of think about 1, well, it has a negative counterpart, negative 1. You think about 2, it has a negative counterpart, negative 2. We're just counting like we normally do. We're just counting a different way now. So the numbers are the same. You go 1, 2, 3, 4, 5. You just have negative symbols in front of them instead. So it's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, so on and so forth. All right, so let's take a look at the integers on a number line. So you'll see that 0 is at the center. And then to the right of 0, you have your positive numbers. Okay? And I'm going to put a plus symbol just out here to say that this is positive. So anything to the right of 0 is positive. Anything to the left of 0, you see how we use these negative signs, okay, directly next to the number to say that these numbers are negative. These are negative numbers. Negative numbers. So again, left of 0 is negative, right of 0 is positive, and 0 is neutral, okay? It's neither. Okay, so to understand the relationship between integers, we need to do some extra thinking. So what if I was to ask you, is negative 4 greater than 1? Is that true? Well, in fact, it's not. And what kind of trips people up is they see 4 and they see 1. And they say, well, 4 is a bigger number. Negative 4 is actually a smaller number. As these numbers that are negative get kind of bigger, meaning you have bigger negatives, they're actually getting smaller. And to see why, let's look at a number line. So you remember in the lesson where we introduced the number line, I told you that as we move right on the number line, the numbers are getting bigger. So meaning 1 is bigger than 0, 2 is bigger than 1, 3 is bigger than 2, 8 is bigger than 4, so on and so forth. If a number is to the right of another on the number line, it is bigger. The same is true if a number is to the left of another on the number line, it's smaller. So 5 is smaller than 6 because it's to the left of 6. Or 2 is smaller than 4 because it's to the left of 4. Well, look, as we're moving this way, we're getting bigger and bigger negative numbers. But again, we're moving left, so the numbers are actually getting smaller. And you can kind of think about this using money if you want. I think that's the easiest way to think about it. If I have negative $4 in my account, do I have more money or less money than if I have $1 in my account? What's the relationship between these two numbers? Well, 1 is a bigger number. Negative 4 is going to be less than 1 because in this case, I actually owe $4. Not only do I not have any money, I actually owe $4 to somebody. So I'm in a much worse situation. So this is a smaller value than 1. So we would say negative 4 is less than 1. And if you ever get confused about it, you can think about it in two different ways. The first way is you can do this. You can draw yourself a little sample number line and say, okay, well, where is this on a number line? Where is this? Again, the one to the left is the smaller number. The second thing you can do is kind of use your common knowledge of numbers that you've worked with in the past. So let's say you have two positive numbers. You have 50 and you have 10. So everybody knows that 50 is a larger number. So 50 is greater than 10. But if I put negatives in front of these numbers, this is no longer true. We would have to flip this to in fact get a true statement. Negative 50 is now a smaller number than negative 10 because negative 50 is a bigger negative number. All right, let's look at a quick exercise here. We want to replace each question mark with the inequality symbol less than or greater than. So we're going to start out with negative 2 question mark negative 5. So what's the relationship between these two numbers? Negative 2 is here on the number line. Negative 5 is here. Again, negative 5 is to the left of negative 2, so it's a smaller number. Remember, I told you that the symbol points to the smaller number. So if we look at negative 2 and negative 5, again, my choices would be to use this symbol, which is the greater than, or this symbol, which is the less than. Point the symbol to the smaller number. Negative 5 is smaller, so we use the greater than. Okay, negative 2 is greater than negative 5. And again, thinking about it the other way, negative 2 is to the right of negative 5, so it's bigger. Or again, thinking about it the way I just said, negative 5 is to the left of negative 2, so it's smaller. Either way, negative 2 is greater than negative 5. What about 1 question mark negative 1? 1 question mark negative 1. So 1 on the number line is here. Negative 1 is here. So negative 1 is a smaller number. It lies to the left of 1 on the number line. So we would have 1, and we would have negative 1, and I want to point the symbol to the smaller number. So again, I'm going to use a greater than symbol. Okay, the greater than symbol is going to point to the negative 1. So 1 is greater than negative 1. And again, if you get confused on something like that, just kind of think about money. If I have $1, do I have more than if I owed $1? Well, yes, I do. So 1 is a greater amount. Let's take a look at negative 7 question mark negative 4. So here's negative 7, and here's negative 4. So negative 7 is to the left of negative 4 in the number line, so it's a smaller number. So we would have negative 7 is less than, again, the symbol's going to point to the negative 7 because that's smaller, negative 4. Okay, now let's talk about opposites, which are also known as additive inverses. So opposites are numbers that have the same distance from 0 on the number line, but lie on opposite sides of the number line. So if you kind of think about this, you would have like 1 and negative 1, 2 and negative 2, 3 and negative 3, 4 and negative 4. Basically, it's just the number and then the negative of that number. So you could make an infinite number of these. You can go through and say, okay, 5 and negative 5, 6 and negative 6, so on and so forth. So with opposites, it's a very easy concept. So to find the opposite of a number, we just change the sign. That's all you're doing, because if I say, hey, what's the opposite of 1? Again, you're just looking for that same value, but just with a different sign. So you would just change the sign and say, okay, well, the opposite is negative 1. So we want to find the opposite of each. And again, you might see this in your textbook if you're in pre-algebra. It might say find the additive inverse. Okay, so just know that those two terms are interchangeable. If I say, hey, find the additive inverse, or I say, hey, find the opposite, they're asking for the same thing. All right, so the opposite of 5 is negative 5. Again, all I do is I take the number and I just change the sign. So this is positive, it becomes negative. The opposite of negative 12 would just be positive 12. Again, just change the sign. The opposite of 315 would be negative 315. Again, just change the sign from positive to negative. And then the opposite of negative 1,718,311 would be positive 1,718,311. Very, very easy to find the opposite of a number. Okay, so now we're going to use this concept to actually look at some problems we're going to deal with. So I have here to simplify each, and we start off with something that looks kind of weird. We have what looks like a negative symbol or a subtraction symbol, and then in parentheses we have negative 4. So what does this mean? Well, essentially when you have this symbol directly next to a number, it's saying, hey, this is negative. This is negative. So I would read this as negative 4. When you have this symbol right here, and it's outside of a set of parentheses, basically what I'm saying is, hey, change the sign of whatever's inside of parentheses. But you could read this as the opposite of. The opposite of. So this would be read the opposite of negative 4. And it's just saying, hey, change the sign of negative 4, what would you get? So whenever you see this, what is the opposite of negative 4? It would be positive 4. Again, just as I showed you with these other examples, when I said, what is the opposite of -4? We just changed the sign. That's all we're doing here. You just have to know how to read it. The opposite of -4 is 4. So that's why we'd write it that way. Now we have the opposite of -3. Again, this is the opposite of, and then this is -3. And again, all that's saying is, hey, whatever's in parentheses, which in this case is -3, change the sign. So whatever's in parentheses, again, this is -3 in parentheses, change the sign, it would be +3. Or if you saw a negative symbol outside of a set of parentheses and there was a positive number in there, let's say it was 5, you would just change the sign of 5. Hey, what is the opposite of 5? -5. Okay, that's all you're doing. Okay, so before I kind of get into the next problem, I want to address something that I haven't talked about yet, but it's the concept of an odd or an even number. So I'm going to briefly talk about this. So an even number is a number that is divisible by 2. And when I say divisible by, I mean you divide it by 2 and you don't have a remainder. Okay? So in other words, 6 divided by 2 is 3. So 6 is an even number. Or 10 divided by 2 is 5. So 10 is an even number. 3 divided by 2 would be 1 with a remainder of 1. That would be not an even number. That's something called an odd number. So an odd number is not divisible by 2. Okay, not divisible by 2. 5 is an odd number. 5 divided by 2 would be 2 with a remainder of 1. So that's an odd number. And again, we'll get more into this when we get to the divisibility rules, but you need to have a basic definition of this to apply this trick that I'm going to teach you. All right, so what about when we see a scenario like this where we have multiple symbols in a row? So we have the opposite of -15. All right, kind of the slow way to do this is to think about, okay, the innermost set of parentheses contains -15. If I kind of move out of that, I would be asking for what is the opposite of this -15 here? Well, it's 15, right? Just change the sign. So kind of contained in these parentheses here, I would just get 15 as a result. So I'd have this negative out here, or again, asking for the opposite of, and then I would have inside of parentheses just a 15. Then this negative, or again, asking for the opposite of, is telling me to change the sign of whatever's in the parentheses one more time. So what is the opposite of 15? Well, that's just -15. So very, very easy, but if you had a longer problem, it would be ridiculously time consuming. The quick way to do this is just to realize that each time you have a pair of negatives, it's going to make a positive, right? So this one and this one are a pair, so that makes it positive, right? You recall that we ended up with a positive 15 inside the parentheses, right? And then we had the negative out there. Now, there's nothing else to pair up with this, so it becomes negative. So you think about a pair as being 2. So 2, 4, 6, 8, 10, 12. These are even numbers. So when you have a pair, things become positive. So all your problems where you have even amounts of those negative symbols will give you a positive. If you don't have an even amount of those symbols, meaning you have an odd amount of those symbols, you get a negative result. We have 1, 2, 3 of those, meaning we could only make one pair of negatives, and then we couldn't do anything with that one, so we had a negative result. We got a -15. If I had the opposite of -15 like that, now I have an even number of these symbols. Now I'm going to get a positive 15. So working backwards, this would make it positive 15. So we'd have the opposite of positive 15. And then this would make it negative. So we would have the opposite of -15. And then this last one would make it positive again, right? We have another pair. So this becomes 15. So just count the number of symbols that you have. Again, pair them up. So in other words, like this is a pair and this is a pair. So we end up with an even number of those symbols, so we get a positive result. Here's one that's pretty long. So we have the opposite of -24. So if you were to kind of work through this the slow way, you'd be like, okay, now this is going to make it positive, this is going to make it negative, this is going to make it positive, this is going to make it negative, this is going to make it positive. You'd end up with positive 24. But the quicker way to do it, again, is just to count the number of symbols you have. You have 1, 2, 3, 4, 5, 6 of them. 6 is an even number. 6 divided by 2 is 3, no remainder. So we know that the answer would be positive. Again, you can kind of also look at it and see, hey, can I pair these up? So this would pair up and become positive. This pairs up and becomes positive. This pairs up and becomes positive. Right? Each pair of those negatives makes a positive. And again, if you kind of look at one, let's say we only had 5. So the opposite of, the opposite of, the opposite of, the opposite of negative 24, like that. Now, this would make it positive. This would make it negative. This would make it positive. And then we'd have one more that would make it negative. So there's only 5. 1, 2, 3, 4, 5. So this would become negative 24 now. Again, it's an odd number. 5 divided by 2 is what? It's 2 with a remainder of 1. So it's not an even number. It's an odd number. So we get a result that is negative. Okay, let's look at one last problem. And look how long it is. So we have the opposite of, 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 the opposite of negative 9. So again, if I could do this the long way, it's going to take some time. So in other words, this would make it positive. This would make it negative, positive, negative, positive, negative, positive, and negative. So we'd have negative 9. Again, the easy way is to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is an odd number. It is not divisible by 2. 9 divided by 2 is 4 with a remainder of 1. So it's an odd number. So that's why we get a negative result. And again, you can also pair them up. You can say, okay, well, this would make it positive. These would make it positive. These would make it positive. These would make it positive. But then this one is hanging out by itself. No other negative to pair with it. So we're going to end up with a negative result. And that's why we have negative 9. Hello and welcome to Pre-Algebra Lesson 18. And in this video, we're going to be learning about absolute value. So for our lesson objectives, we want to learn how to find the absolute value of a number. And also we want to learn how to simplify when absolute value is present. So in our last lesson, we were introduced to a new group of numbers known as the integers, right? And this allowed us to see some negative values or some values to the left of 0. So before we start working with these integers, adding and subtracting, multiplying, dividing, it's important that we learn the definition of absolute value. So if we look on the screen here, we see that the absolute value of a number is the distance, okay? The distance between that number and 0 on the number line. So what if I started out by asking you, what is the absolute value of the number 3? And the way we're going to ask for this is we're going to have these vertical bars around the number that we want to find the absolute value for. So this right here is basically saying, what is the absolute value of 3? Okay, that's what this means. Again, the vertical bars are surrounding the number we're trying to find the absolute value for. Now, following our definition that we were given, the absolute value of a number, again, is the distance between that number and 0 on the number line. So if I find 3 on the number line, and I find 0 on the number line, I just need to count how far away it is. And it's just 1, 2, 3 units away. So the absolute value of 3 is just 3. Now, one thing I want you to note right away, what if I asked you for the absolute value of negative 3? You're going to find that you're going to have the exact same absolute value because it's 1, 2, 3 units away from 0 as well. So the absolute value of negative 3 is also equal to 3. This goes back to our definition of opposites. Remember in the last lesson where we talked about opposites, we said that opposites were numbers that lied on opposite sides of the number line. So in this case, you have 3 and negative 3. They're on opposite sides. And they had the same distance from 0. So this one has the distance of 3, right? You have to travel 3 units to the right to get to 0. This one has the distance of 3. You have to travel 3 units to the left to get to 0. So opposites are always going to have the exact same absolute value because they have the same distance from 0 on the number line. So for example, if I said, what is the absolute value of 7? And what is the absolute value of negative 7? In each case, the answer is going to be 7. Right? If I look at 7 and negative 7, in each case, I have to travel 7 units to get to 0. right? 1, 2, 3, 4, 5, 6, 7. And from here, 1, 2, 3, 4, 5, 6, 7. So the absolute value of 7 is 7, and the absolute value of negative 7 is 7. So another thing I want you to note right away is that the absolute value of a number is never going to be negative. It's always going to be 0 or some positive value. And the reason for that is absolute value represents a distance, and a distance is not going to ever be negative, right? For example, in real life, you think about waking up and going to work. You can either not go to work and drive 0 miles, or you can drive some amount of miles. It could be 10 miles, 20, whatever it is. Doesn't matter. And I know some of you will put in the comments that you could back up, but no, that's not driving a negative amount. Sorry. Do we really need to pull out a number line every time we want to find the absolute value of a number? Of course not. The rule is if the number is negative, just make it positive. So for example, if I asked you for the absolute value of negative 37, you would just make it positive. It would just be 37, right? Essentially, if it's negative, make it positive. Negative 37 would be 37 units away from 0 on the number line. If the number is 0 or positive, keep it the same, okay? So if the number 0, so if you have the absolute value of 0, 0 is 0 units away from 0 on the number line, so it's just 0. If it's some positive value, let's say it's, 42. It's just that number, right? It's going to be 42 units away from 0 on the number line. All right, let's look at a few problems. So we want to find the absolute value of 19. So again, if it's a positive number, just keep it the same. So the absolute value of 19 is just 19. Because if we had a number line there, I would count 19 units to the left to get to 0 if I started from 19, right? It's 19 units away. So the absolute value of 19 is just 19. What about the absolute value of 0? Well, again, 0 is 0 units away from itself on the number line, so the answer is 0. What about the absolute value of negative 24? Again, if you have a negative number, just make it positive. So I make this positive, and I get 24. Okay, what about the absolute value of negative 34,422? Well, again, if it's a negative value, just make it positive. So this would just be 34,422. Okay, now we want to replace the question mark with the correct symbol. So we have less than, greater than, or equal to. Okay, for the first one, we're going to look at the absolute value of negative 27, question mark, the absolute value of 22. All right, so first let's think about what these are worth. So the absolute value of negative 27 is 27, and the absolute value of 22 is 22. Again, for this one, it was negative, so we just made it positive. For this one, it was positive, so it just stayed the same. So if we think about the relationship here, the absolute value of negative 27 is a larger number, so it's greater than the absolute value of 22. And again, the reason for this is because this ends up being 27 after we apply the absolute value. So 27 would be bigger than 22. And again, you want to point the symbol towards the smaller number. Okay, now we have the absolute value of 0, question mark, the absolute value of negative 5. So the absolute value of 0 we know is 0. The absolute value of negative 5 is 5. Again, just change the sign from negative to positive. So which one's going to be bigger? Is 5 bigger or 0 bigger? Well, 5 is bigger. So the absolute value of 0 is going to be less than the absolute value of negative 5. Again, the symbol is going to point to the smaller value. What about the absolute value of negative 7, question mark 7? Well, in this case, the absolute value of negative 7 is 7. So 7 and 7 have the same value, so we're going to use an equal sign. So we're going to say the absolute value of negative 7 is equal to 7. So sometimes we're also going to have to simplify when we're working with absolute value. And one of the things you have to be careful about, in the last lesson, I kind of gave you a little trick on how to simplify when you have a bunch of negatives involved. So I want you to look here and see that we have what? We have the opposite of the absolute value of negative 13. Now, let me just kind of put this to the side for a second. I want to show you this problem. So let's say we had the opposite of negative 13. We would count the number of those symbols we have. And again, if it's even, divisible by 2, the result is positive. If it's odd, not divisible by 2, it's negative. So here we have 1, 2 of those symbols. So that's an even number. So the answer is positive, right? Because you have the opposite of negative 13, that's just 13. Now, when you're working with absolute value, you can only count the number of symbols you have outside of the absolute value bars. And the reason for that is because remember, the result of the absolute value operation always makes things non-negative. Okay, always makes it non-negative. So the least it's going to be is 0. Now, thinking about this, if I count only the negatives outside of this operation here, I only have 1. 1's an odd number, so I know the result's going to be negative 13, right? Please don't make the mistake of trying to apply that trick with absolute value and getting it wrong, because some students will say, okay, I have 1, 2 of those symbols, 2's an even number, I got positive 13. No, because when you evaluate this the slow way, you would say, okay, the absolute value of negative 13 is positive 13, right? You make the negative positive, and then you have the opposite of positive 13, which becomes negative 13. So pay close attention when you have the absolute value operation involved. Okay, now we have the opposite of the absolute value of 21. So again, I would count the number of these symbols that I have outside of my absolute value bars. So I have 2 of them. 2's an even number, so my result would be positive. But again, if you want to kind of do this the slow way, you have the opposite of, the result of this would be 21. So the absolute value of 21 is just 21, right? If it's positive, keep it the same. So we'll put this in parentheses. So this would be 21 here. And the opposite of 21 would be negative 21. So let's write this as the opposite of negative 21. And then one more time, we'll change the sign to positive 21. But again, the shortcut, count the number of those symbols you have outside of the absolute value operation. And that's going to tell you if it's even, you're going to have a positive number. If it's odd, you're going to have a negative number. Okay, here we have the opposite of, the absolute value of negative 53. Again, pay attention. You have 1, 2, 3 symbols outside of your absolute value operation. Please don't count this one, because this one right here, you got to think about it. When we're done with this absolute value operation, this is going to be a positive number. It's not going to be negative, right? It's different than if I had the opposite of negative 53. In this case, this ends up being a positive 53, right? Because I have 1, 2, 3, 4 negatives. 4 is an even number. I'm going to end up with positive 53. This becomes positive, then negative, then positive. Here it's going to be different because I start out, basically you can think about this right here, it's just positive 53. The absolute value of negative 53 will be positive. So this is positive, it's not really negative. So this will end up going to negative, then positive, then negative, right? So that's why you'd end up with negative 53. Again, doing this the slow way, let me kind of show you this. The absolute value of negative 53 is 53. So I'm going to put that in parentheses. Now, change the sign. So this will become the opposite of 53 is negative 53. So the opposite of negative 53. Change the sign again. So it'll become positive 53. So the opposite of 53. And then change the sign one last time to negative 53. And again, I can't repeat this enough. If I just look at how many of these signs I have outside of the absolute value operation, if it's odd, which in this case I have 1, 2, 3, 3 is an odd number, I know I'm going to get a negative result. If it's even, right, divisible by 2, I know I'm going to get a positive result. Okay, last problem. We have the opposite of, and then the absolute value of 6 plus 3. Now, again, I can count the number of symbols I have outside of the absolute value operation. I have 1, 2, 3. So I know the result's going to be negative. Basically, I can just kind of eyeball this and see that I'm going to have the absolute value of 6 plus 3, which is 9. And I know I'd have negative 9, right? It's a very, very simple problem. But let's kind of go through it the slow way. So let's copy this, the opposite of, and then we know 6 plus 3 is 9. So inside of absolute value bars, we'd have 9. And even at this point, we can see we'd have negative 9 as a result. But again, let's keep going. So now we just take the absolute value of 9. That's 9. So we'd have the opposite of, and then we'd have 9. And now we would just go through and take the opposite. So the opposite of 9 would be negative 9. So we'd have the opposite of negative 9. Then take the opposite of negative 9, you get positive 9. So the opposite of positive 9. And then the opposite of 9 is just negative 9. So absolute value is a very easy concept overall. You just have to remember, if you're taking the absolute value of a negative number, make it positive. If you're taking the absolute value of 0 or a positive number, just keep it the same. Hello and welcome to Pre-Algebra Lesson 19. In this video, we're going to learn about adding integers. So the lesson objectives for today, we want to learn how to add integers using a number line. So this will give us a visual representation of what's going on, and it can be helpful if you're struggling with this topic. And then we're going to move on and learn how to add integers without a number line. So this is how we're going to solve our problems moving forward. Okay, so let's start out by talking about the scenario where we're going to use a number line. And basically, we'll start with the easier scenario where we're adding 2 or more integers with the same sign. So a positive plus a positive, which we already know how to do, or a negative plus another negative. So I have here that we would start at the left number that's on the number line. Then this plus here, this is basically for a positive number. If you have a positive number, it indicates a movement right. So for example, let's say I had 4 plus 5. We know that we could start out at 4 on the number line. And then because this is a positive number, I know that I'm going to move to the right. And in this case, I would move to the right by 5 units. And of course, we all know that 4 plus 5 is 9. Let's slide down here. And we see that this right here is for a negative number. And this indicates a movement left. So if I'm adding a negative number, basically I'm going to move to the left. So let's say I had something like 4 plus negative 5. Or actually, let's do negative 4 plus negative 5 to have the same sign here to make it a little bit easier. What's going to happen is I'm going to start out at negative 4 on the number line. And because I'm adding a negative number here, I'm going to move to the left by the absolute value of that number. So the absolute value of negative 5 is 5. So I'm going to start at negative 4 and go 5 units to the left. And that's going to put me at negative 9. And we'll see this in a moment. So I have here, use the absolute value of the number being added to determine how far to move. Let's look at some examples. We want to add each on the number line. And this is not going to be bad at all. Once you do a few of these, it's really, really easy. Okay, so the first thing is, when we look at the number line, remember 0 is not positive and it's not negative. So it is neither. If I look to the right of 0, those are the positive numbers. To the left of 0, those are the negative numbers. As we move to the right, remember numbers are increasing in value. And if we move to the left, numbers are decreasing in value. So it's really important to remember that. So let's start out with 4 plus 5 on the number line. Again, all I have to do is start out at 4. And I'm going to add 5. So again, this is a positive number that I'm adding. So I'm just moving to the right by, you could say, the absolute value of that number there, but the absolute value of 5 is just 5. So I'm just moving to the right by 5 units. So 1, 2, 3, 4, 5 units. So I end up at 9. So let me circle the starting and the ending. So we know that's 9. If I start with $4 and I make $5 today, well, now I have $9. So that's pretty simple. All right, the more challenging scenario occurs when you add 2 negative numbers. So thinking about negative 4 plus negative 5, well, we saw, let me put a little border here, that 4 plus 5 was equal to 9. Well, here with negative 4 plus negative 5, you would start at negative 4. So let me start here, and I'll just circle that. And I'm going to add a negative number. So that means I'm going to go to the left, okay? And I'm going to go to the left by the absolute value of that number. So the absolute value of negative 5 is 5. So in other words, the sign here is telling me the direction. If it's positive, I'm going to the right. If it's negative, I'm going to the left. And then the absolute value of the number is telling me how far to move. So here I'm just moving 5 units to the left. So I'm going 1, 2, 3, 4, and then finally 5 units to the left. I'm going to end up at negative 9 there. Okay. And we can do this in our head if you just think about it with money. Let's say that I owe $4 currently. I owe $4 to maybe the bank or something like that. And I go out and I accumulate another debt of $5. So let's say I go out with my credit card and I spend $5. Well, how much do I owe? Well, I can just add those two debts together. Negative 4 plus negative 5 would be negative 9. That's something you do in your head. You just say, okay, 4 plus 5 is 9. And then I'm attaching the common sign, which is negative, to show that I owe money, right? So I owe $9, or I could say it's negative 9 for the sum. Let's take a look at another one. Here we have a negative 2 plus negative 3. Before I do that, let me come over here and just do 2 plus 3. So again, you can see that there's a pattern emerging. So 2 plus 3 is what? That's 5. I could start at 2,
and I could just go 1, and that color doesn't really show up. So let me change to orange here. So 1, 2, 3 units to the right, and I end up at 5. Okay, let me erase this and go back to -2 plus -3. So here I would start at -2. So let me put that there, and I'll circle this. I'm adding a -3. So again, if I'm adding a negative, the negative tells me I'm going to the left, and then by the absolute value of this number of units. So the absolute value of -3 is 3. So I'm going to the left by 3 units. So 1, 2, 3 units, and I end up at -5. So this is -5. Again, notice you got 5 here, and you got -5 here. So I can just add the absolute values here and attach the common sign. If I owe $2 and then I owe another $3, well, that's 2 plus 3 or $5 that I owe. So that can be represented with -5. So all you're going to end up doing is adding the absolute values of the numbers. So just pretending like they're positive and then just attaching the common sign. Here again, you just say, okay, what if they were positive? So 2 plus 3 would be 5, and then attach that common sign, which is negative. Okay, let's look at one with more than 2 integers. So now we have 3 integers, all the same sign. So it's not really any harder. You're going to have -1 plus -2 plus -5. So if I start at -1 and I add -2, I'm just going to the left by 2 units. So 1, 2 units to the left. So that's going to put me at -3. And then I add another -5. So I'm going to go 5 units to the left. So 1, 2, 3, 4, 5. So I'm going to end up at -8 there. So I started at -1, I ended up at -8. So let me put -8 here. And again, you can think about this by just adding whole numbers. Let's say I had 1 plus 2 plus 5. 1 plus 2 is 3, 3 plus 5 is 8. Again, because all the signs here are negative, you would just attach that common sign. So I have a debt of $1 plus another debt of $2 plus another debt of $5. Let's say I owe Steve $1, I owe Chris $2, and I owe Mary $5. Well, how much do I owe in total? I can just add those guys together, and I get a total debt of $8, which I can represent with -8. Okay, let's just do one more with the number line, and then we'll move off of it. So we have -4 plus -3 plus -1. So let's start at -4. And then we're adding -3, so I'm going to the left. 1, 2, 3 units. So that puts me at -7. And then I'm adding -1. So I'm going 1 more unit to the left. So I started at -4 and I end up at -8. So this is -8. Once again, you could just add 4 plus 3 plus 1. So 4 plus 3 is 7. 7 plus 1 is 8. And you're just attaching the common sign. I owe $4. I have another debt of $3 and another debt of $1. How much do I owe in total? Well, I owe $8, which can be represented with -8. All right, so let's look at the rule, which I think is pretty easy at this point to understand. When adding 2 or more integers with the same sign, you add the absolute values and keep the common sign. So very, very simple. So I have here, let's try a few without the number line. We have -15 plus -11. So again, this is negative and this is negative. So just put a negative and then just pretend these two numbers are positive. What if I added 15 and 11? A lot of you can do that in your head. You know it's 26. But if you need to do a vertical addition, we can always stop and do that. 5 plus 1 is 6. 1 plus 1 is 2. So you just drag that up there and say this is -26. I owe $15 and then I go out and charge up another $11 on my credit card. How much do I owe in total? Well, I'm going to owe $26. So I can just say that's -26. What about this one? We have -7 plus -1 plus -3. Again, this is negative, and this is negative. So the answer is negative. Just use the common sign. Then just pretend like the numbers were positive. What if I added 7 plus 1 plus 3? 7 plus 1 is 8. 8 plus 3 is 11. So just put that here behind that common sign. So this becomes -11 as the answer. Let's do another one. So here we have -5 plus -1 plus -6 plus -14. So every sign here is negative. So the answer is negative. And then just add the absolute values. So 5 plus 1 is 6. 6 plus 6 is 12. And then 12 plus 14, I think a lot of you know that's 26. You can do it in your head, but let's just do it off to the side just so nobody's lost. 2 plus 4 is 6. 1 plus 1 is 2. So you're just going to bring that over here and say that the answer is -26. All right, so now let's move on and talk about the more complicated scenario. So this is where we're going to add 2 integers with different signs, or sometimes you'll add more than 2 integers. So you'll have many integers that you're trying to add and the signs are mixed. So what happens when we have mixed signs? Let's revisit our number line and try a few problems. Now, before we do this type of problem gives students the most trouble. When you look at, let's say, -8 plus -4, again, this is just an addition problem. We just saw this. Basically, you use the common sign is negative, and then you're just adding, right? You're just saying, well, what is 8 plus 4? That's 12, and then you're just attaching that sign. So this is negative 12, so that's really easy. I'm just going to tell you before we start this procedure is just as easy. You're now just doing a subtraction problem, okay? So think about negative 8 plus 4 first on the number line. So here's negative 8, and then I'm adding 4. So that means I'm going 4 units to the right. So I'm just going to go from right here, 1, 2, 3, 4 units to the right. So that puts me at negative 4. Does that make sense? I always tell people to use money in your head if you're trying to think about this. Let's say I have a bank account and currently I owe them $8. I go into the bank and I give them $4. Do I still owe money? Yes, I still owe $4. So it makes sense that this is negative 4 here. Again, I have not given them enough money to get back to 0 or to get back to where I don't owe any money. So basically, you could think about always that if I have a negative here, let's say it's negative 8, that I have to add the opposite of that number. So let's say in this particular case, that's going to be positive 8 to get back to 0. And we could think about that problem. Let me erase this. So if I have negative 8, which is 8 units away from 0 on the number line, remember the absolute value of negative 8 is 8, I would have to go 1, 2, 3, 4, 5, 6, 7, 8 units to the right to get back to 0. So I have to add the opposite of the number to get to 0. Now, if I start adding numbers that are greater than 8, what's going to happen is now I'm going to have a positive balance in my account. Let's say I do negative 8 plus 9. Well, I'm going to go 1 more unit to the right on this number line, and I'm going to end up at 1 now. So now I have $1 in my account because I paid more money than I owed. So hopefully that does make sense. You can pause the video and really start to think about what's going on here. But essentially, this is going to translate into a nice little procedure for us. All we really have to do is first think about which number is bigger in terms of its absolute value. So which number has the bigger distance away from 0 on the number line? Let me get rid of this and go back to this as the original problem. Well, in this case, the negative 8 does, right? It's 8 units away from 0 on the number line. 4 is 4 units away from 0 on the number line. So this guy is going to be the winner in terms of our sign. So you use the sign of the number with the larger absolute value. Then I'm just going to put this in parentheses for right now. You think about these two numbers as if they were positive numbers, and you just subtract the larger minus the smaller. That's all you have to do. So it just becomes 8 minus 4. So 8 minus 4. And so this becomes the negative of 8 minus 4 is 4. So this is negative 4. Let's say you change this around, and now you have 8 plus, let's say, negative 4. Well, this is going to be a positive result. You could put a plus out here if you want, or you can leave it off. It's up to you. And then you're just going to subtract the absolute values. So what is 8 minus 4? So 8 minus 4, well, that's going to be 4. And that should make sense in this particular case. If I had 8, let me get rid of this problem right here. If I had $8 in my account, so let's start here, and I spend 4, or I have a debt of 4, let's say I charge up 4 on my credit card, well, basically when I settle up, I'm going to have $4. So I'm going to go 1, 2, 3, 4 units to the left, and I'm going to end up at 4. So we'll see later on that 8 plus negative 4 can be directly written as 8 minus 4. You can immediately go to that. So if I had something like, let's say 10 plus negative 5, I'll immediately just write that as 10 minus 5. So this is a very easy problem to do a conversion with. If you have something like, let's say negative 10 plus 5, well, this one's a little bit more tricky because the negative has the larger absolute value. So in this case, I just say, okay, well, I'm going to use the negative, and now I'm going to convert this into 10 minus 5 in my head. 10 minus 5 is 5, so this gives me negative 5. Okay, let's look at a few more. So here we have a 9 plus negative 7. So let's start out at 9 on the number line, and I'm adding negative 7. So I've incurred a debt of $7, or let's say someone took $7 away from me for a product that I bought, something like that. So I'm just going to move to the left by 1, 2, 3, 4, 5, 6, 7 units. So I end up at 2. So basically, you could have written this as 9 minus 7, which equals 2. Again, the larger absolute value here is 9. 9 is 9 units away from 0 on the number line, and negative 7 is 7 units away from 0 on the number line. So basically, I'm not taking away enough to get me to 0 or some negative value, so the answer is going to be positive. Right? And then you could just subtract the absolute values. 9 minus 7 is 2. If I change this around, let me put this a little bit tighter in there. If I change this around, and let's say I do negative 9 plus 7, well, now I owe $9, right? So I'm here at negative 9. I go into the bank and I give them 7. Now I still owe $2. So I've got to go 1, 2, 3, 4, 5, 6, 7 units to the right. And now I'm at -2, right? So I started at -9 and I'm at -2. So I have not gotten out of the hole yet. So here you would say this is the negative of, and then you go 9 minus 7. So 9 minus 7. And let me make that 7 a little bit better. So this becomes -2. Okay, let's look at one more of these and then we'll just run through a bunch of examples. So we have -7 plus 12. So start out at -7 and I'm going to add 12. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I end up at 5. So here's -7. Again, that should make sense. If I owe $7 and I pay $7 off, I'm going to be at 0. But now I didn't just pay $7 off, I paid $12 into my account. So I should have $5 more left in my account. So this really becomes a subtraction problem. It becomes 12 minus 7, which is 5. Again, if this number is larger in terms of absolute value, you could just flip it around and turn it into a subtraction problem. You could really just say, okay, well, this is going to be 12 plus -7, which becomes 12 minus 7, which equals 5. This is something you're going to do mentally very, very shortly after you start working enough problems. If you started with something like -12 plus 7, well, then in this case, I owe $12, but I'm only paying off 7. So it makes sense that I should still be in the hole, right? Or have a negative account balance. So this will be negative. And then I'm just going to say, okay, what is 12 minus 7? Just subtract the absolute values, the larger minus the smaller. 12 minus 7 is going to be 5. So this ends up giving me -5. All right, let's go through the procedure and then we'll just run through a bunch of problems. So when adding two numbers with different signs, use the sign of the number with the larger absolute value. Then think about the numbers in terms of their absolute values and subtract the smaller from the larger. So you're doing a subtraction problem, figure out what your sign is, and then just subtract the absolute values, larger minus smaller. That's all it is. Okay, so let's try a few without the number line. So here we have 13 plus -8. Again, you can easily convert that in your head into 13 minus 8. And the reason is simple. This guy is larger in terms of absolute value. I have $13. You could say I'm incurring a debt of $8. Whatever it is, I'm taking 8 away from what I have. So 13 minus 8 would just be 5. So the sign of the number with the larger absolute value is positive, and then you're subtracting the larger absolute value, which is 13, minus the smaller absolute value, which is 8. 13 minus 8 would give you 5. If you had -13 plus 8, well then the 8 that you're adding is not enough to cover the debt, right? You owe $13. So this guy will be negative. The larger absolute value is negative, so this sign will be negative, and then you're just doing what is 13 minus 8, which gives you now -5. So that's the difference between these two. I started with 13, which is a bigger number in terms of absolute value, and I added a debt of 8, or I subtracted away 8, however you want to think about that. Basically, I'm going to end up with $5 in my account. Here I owe $13 and I only pay off 8, so I'm going to have a negative here, and then I do 13 minus 8, I end up with a debt of $5. So that's the difference between these two. What about 12 plus -2? Again, the absolute value of 12 is bigger than the absolute value of -2, so this will be positive. And then you could just subtract the larger absolute value minus the smaller. So this turns into 12 minus 2, which is 10. If I had -12 plus 2, well, now this is going to be negative. I owe more than I'm putting back in. The absolute value of -12 is larger than the absolute value of 2, so this is going to be negative. And then you do the same subtraction. You're still going to do 12 minus 2. So this part's still 10, but I have that negative there. So this would be -10. What about 14 plus -23? So the absolute value of 14 is 14. The absolute value of -23 is 23. So we know this is negative, and then you're just going to do a subtraction. What is 23 minus 14? Let's borrow here and put a 1 there. 13 minus 4 is 9. 1 minus 1 is 0, so this is -9. And again, if you change this up and you said, well, I have -14 plus 23, well, now I owe $14 and I'm putting 23 in my account. So of course I expect to have a positive balance, right? So the sign of the number with the larger absolute value is positive. So the answer would be positive. And now you can just change this into 23 minus 14, which of course we know is 9. What about -31 plus 25? Well, here the sign of the number with the larger absolute value is negative. So we're going to use that sign. And then you're just going to subtract the absolute values, larger minus smaller. So 31 minus 25. Let's borrow here and put a 2. Maybe that 5 could look a little bit cleaner. And let's put this as an 11. 11 minus 5 is going to be 6. 2 minus 2 is 0. So this would be -6 here. And again, if you had changed that up and said you have $31 and you add a -25, So basically you spend 25 or you incur a debt of 25, however you want to think about that. Well, what's going to happen is I have enough money to cover that. So I know I'm going to have a positive balance in my account because the absolute value of this positive number is larger than the absolute value of this negative number. And then I just do my subtraction. So larger absolute value minus the smaller. What is 31 minus 25? We know that's 6. So here that would be 6. Okay, let's do some problems where it's mixed. So what I'm going to tell you is when you do mixed addition, the way I like to do it is I like to add the numbers with the same sign first. It just makes it easier. You can reorder this using the commutative property. You can always add in any order. So I'm just going to say that this is 12 plus 7 done first, and then plus negative 15. So we know 12 plus 7 is 19. Been doing that forever. So this is 19 and then plus negative 15. And then of course here, 19 has the larger absolute value. So the answer will be positive. And then you're just doing a subtraction. So larger absolute value minus smaller. So what is 19 minus 15? Well, that's going to be 4. What about 5 plus negative 2 plus 1 plus negative 7 plus 11 plus negative 14? So let me put 5 plus 1 plus 11 next to each other. And then plus negative 2 plus negative 7 plus negative 14. I'll put those next to each other. And again, just add the numbers with the same sign first. So those guys, let me do this in a different color. And those guys, you'll do them separately. So what is 5 plus 1? That's 6. 6 plus 11 is 17. Again, you can always stop and do a vertical addition. 1 plus 6 is 7. Bring down the 1. So that's 17. So this right here would be plus. Now you have negative 2 plus negative 7 plus negative 14. So I know that's negative. And then just add 2 plus 7, that's 9. And then 9 plus 14, a lot of you know that that's going to be 23. But 4 plus 9 is 13. So put the 3 down, carry the 1. 1 plus 1 is going to be 2. So this would be negative 23 here. So now, which number is larger in terms of its absolute value? Well, negative 23 is. So this would be a negative. And then you're just doing a subtraction. So what is 23 minus 17? A lot of you, again, know that's 6 already. But let's just do this over here so nobody is lost. Borrow here, and that 1 could be better. So this is 13 minus 7, which is 6. 1 minus 1 is 0. So this right here, you drag that up, and you would get negative 6 as the final answer. All right, let's take a look at one more of these. So here we have negative 3 plus negative 1 plus 8 plus negative 5 plus 9. So let's write negative 3 plus negative 1 plus negative 5 plus 8 plus 9. Okay, so negative plus negative here would give me a negative. And then just add the absolute values. So 3 plus 1 plus 5. 3 plus 1 is 4. 4 plus 5 is 9. So this is negative 9. And then plus, we know 8 plus 9 is 17. So now, if you think about this, this number is larger in terms of its absolute value. So our answer will be positive. And then you're just subtracting the larger absolute value minus the smaller. So you're just turning this around into what is 17 minus 9. And a good way to do this, I think, is to just reorder that and say this is 17 plus negative 9. When I see that immediately, I know that's 17 minus 9. And of course, that gives me a final answer of 8. Hello and welcome to Pre-Algebra Lesson 20. In this video, we're going to learn about subtracting integers. So the lesson objective for today, we're just going to learn how to subtract integers. And the procedure for this is pretty straightforward. If you know how to add integers, then you can automatically subtract integers. So I have here, the first thing you'd want to do is to leave the first number, and that means the leftmost number of the subtraction problem. We call that the minuend. This is going to be unchanged, so don't mess with that at all. The second thing is you're going to change the subtraction operation into addition. So instead of a minus, you're going to put a plus. Then the last thing is to change the second number. So that's the rightmost number of the subtraction problem. We call this the subtrahend. We're going to put this as its opposite. So just change the sign of the number. So basically you're changing your subtraction problem into addition of the opposite. Let's take a look at a few problems using the number line. I think this is not too bad overall. If you can add integers, then you can subtract integers. It's basically the same thing with just an additional step. So here we have 7 minus 9. So before we do anything, let's just think about this logically. If I have $7 in my account, then I can only spend $7 before I go negative. I think we all know that. So if I'm spending $9, well, I'm spending $2 more than I have, so I should expect to have a balance of -2. So if I think about this, using my procedure, I would keep the first number unchanged, so just write a 7. Then change this subtraction into addition, and then change the number being subtracted away. In this case, it's 9. You're going to put that into its opposite. So just change the sign. For +9, it would become -9. So this is 7 minus 9 is the same thing as 7 plus negative 9. So I have 7 and you take 9 away from me. It's the same thing as if I said, hey, I have 7 and I have a debt of 9 and we're going to settle up, right? So you're taking 9 away from me. It's the same thing either way. So when I think about this, using my procedure for adding integers, well, I want to use the sign of the number with the larger absolute value. The absolute value of negative 9 is 9. The absolute value of 7 is 7. So negative 9 has a larger absolute value. So we get a negative for the result. Now you're just going to do a subtraction. So you're going to do larger absolute value minus the smaller. So what is 9 minus 7? And this ends up giving me 9 minus 7 is 2. You apply the negative. This is negative 2. But we knew that already because we just thought about it logically. If I have $7 in my account and I spend $7, I'm at 0, but I'm spending 9. So I'm spending 2 more than what I have. So I should expect to be at negative 2 for my account balance. You can also think about this on the number line. Let's say again, we start out at 7. So this is my account balance here. And I take away 9, or you could say you add negative 9, whatever you want to do there, you're basically going to move 9 units to the left. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and then finally 9. So I started at 7. Notice when I added negative 7 or subtracted away 7, I got to 0. And then if I subtract 2 more away or I add another negative 2, I'm going to be at negative 2 for the result. So 7 minus 9, which is the same thing as 7 plus negative 9, gives us negative 2. Okay, let's look at a similar problem. So here we have 5 minus 11. So again, if I have $5 in my account and I go through and I buy $11 worth of stuff, I know that I overspent by $6, right? Because if I spend $5, I'm at 0. And then basically I'm going to spend another 6 from what I have. So that's going to put me at negative 6. Well, we can show this by saying that I have 5, keep that leftmost number the same. I'm going to change the minus into a plus. So now this is addition. And I'm going to change that 11 into its opposite. So that will be negative 11. So this becomes what? Use the sign of the number with the larger absolute value. So negative 11 has a larger absolute value, so this will be negative. And then inside, just subtract the smaller absolute value from the larger. Or you can say the larger absolute value minus the smaller. However you want to think about that, it's going to be 11 minus 5 inside. So 11 minus 5 is 6. So this becomes negative 6 as the answer. Again, using the number line to see this visually, if you need that, here's 5. So I start out with $5 in my account, and I'm going to spend 11. So first, let's say we spend 5. So 1, 2, 3, 4, 5 units to the left. At that point, I'm at 0. So there's no more money in my account. Well, basically, I'm going to go another 6 units to the left because I'm spending $6 more, or I'm adding another negative 6, however you want to think about that. So I'm going to go another 1, 2, 3, 4, 5, 6 units to the left to end up at negative 6. So basically, I started out with 5 and I added negative 11, or I took 11 away and I went 11 units to the left on the number line. So I end up at negative 6, or I owe $6 to the bank, however you want to think about that. Okay, we'll do one of these without a number line, and then I'm going to change it up a little bit. I'll go back to the number line. So for this one, we have 15 minus 18. So just write this as 15 plus a negative 18. So it starts to become pretty quick for you. Leave this first number unchanged. So 15 is unchanged. Change your subtraction to addition. Change the number being subtracted away into its opposite. So 15 minus 18 is 15 plus negative 18. So the negative 18 has the larger absolute value, so we'll use that sign. And then you're just going to subtract the larger absolute value minus the smaller. So 18 minus 15. So this becomes the negative of 18 minus 15 is 3. So this is just negative 3. Again, if I start with $15 in my account and I spend 18, so I'm taking 18 away from what I have, I would expect to basically have negative 3 because I spent $3 more than what I had. Okay, for this problem, we will return to the number line. So the leftmost number, you'll notice that that's a negative now. So this is actually going to make the problem a little bit easier. So let's just go with our procedure. The leftmost number is negative 5. I'm not going to mess with that. I'm going to change my subtraction operation into addition, and then I'm going to change the number that's being subtracted away. Here, that's positive 3. I'm going to put that as its opposite, so this will be negative 3. So we can write negative 5 minus 3 as negative 5 plus negative 3. And so we have this common sign that's negative, so the answer will be negative. And then you just add the absolute values. So 5 plus 3 would be 8, so the final answer here is negative 8. I think it's also useful to see this on the number line. So let's say that I start with negative 5. So I'm starting with this leftmost number here. And then whether I think about this as subtracting away 3 or adding -3, I'm moving 3 units to the left. So I'm going 1, 2, 3 units to the left. So I started at -5. I'm going to end up at -8. All right, what about -56 minus 18? So this would be -56 plus a -18. So basically, you know this would be negative because that's the common sign. And you could just add 56 plus 18. Some of you can do that in your head. It's going to end up being 74. But let's just go through this. So 6 plus 8 is 14. 4 down, carry the 1. 1 plus 5 is 6, plus 1 is 7. So that's 74. So this becomes a -74 for your final answer. What about -107 minus 29? So let's say this equals -107 plus a -29. So we know the answer is negative, and you're just going to say, well, what is 107 plus 29? So just add the absolute values. 7 plus 9 is 16. 6 down, carry the 1. 1 plus 0 plus 2 is 3. Bring down the 1. So this is 136. So again, drag that up there. We'll say the final answer is -136. All right, now let's talk about something that gives students a lot of trouble in this section, and that is subtracting away a negative is the same as adding a positive. So you might see something like 4 minus a -3, and we say that's equal to 4 plus 3. So minus a negative is plus a positive. I'll give you a little bit of an explanation in a moment. For right now, let's just use the procedure that we talked about earlier. So for the leftmost number, the minuend is going to stay the same. So this is 4 and this is 4. The subtraction operation becomes addition. So this is a minus and this is a plus. And then the number being subtracted away, again called the subtrahend, this guy is going to get changed into its opposite. So the opposite of -3 is +3. So just following the procedure we already talked about, you would get the right answer. So this becomes 4 plus 3, which we know is 7. You see that I have 4 minus 2 equals 2, 4 minus 1 equals 3, and 4 minus 0 equals 4. You'll see that each time the number that's being subtracted away, or the subtrahend, decreases by 1, the difference, or the result from the subtraction operation, increases by 1. That should make sense because I'm taking 1 less away, so the result, or the difference, should be 1 larger. So 4 minus 2 is 2, 4 minus 1 is 3, 4 minus 0 is 4. So now when we get into 1 less than 0, well, that's going to be -1. So I have 4 minus a -1, which gives me 5. So it's the same thing as if I said, what is 4 plus 1? Well, that's 5. Then 4 minus a -2, that's 4 plus 2, that's 6. Then 4 minus a -3, that's 4 plus 3, that's 7. Let's look at some examples. So here we have -7 minus a -20. So this becomes -7 plus 20. So again, minus a negative is plus a positive. Keep this first number unchanged, change the subtraction into addition. This number right here that's being subtracted away, it's -20, it becomes its opposite, which is +20. So this is what? The sign of the number with the larger absolute value is positive, and so you're just going to change this over into 20 minus 7, which becomes 13. What about -13 minus a -6? So -13 plus 6. Minus a negative is plus a positive. So the sign of the number with the larger absolute value is negative. So this will be a negative, and then just subtract the larger absolute value minus the smaller. So this is 13 minus 6. So this becomes negative. 13 minus 6 is 7. So -7. What about -94 minus a -17? So -94 plus 17. Minus a negative is plus a positive. So let me say that the sign of the number with the larger absolute value is negative. And then you're just going to go 94 minus 17. So in other words, you're saying the larger absolute value minus the smaller. So 94 minus 17. So this gives me what? Let me borrow here, put an 8, and this will be 14. 14 minus 7 is 7. 8 minus 1 is 7. So this would end up being -77. All right, let's wrap up the lesson. And what we're going to do now is talk about multiple operations. So basically subtracting more than 2 integers. So when we perform subtraction with more than 2 integers, the rules are the same. Change each subtraction to addition of the opposite. This is going to help you a lot because remember, addition is commutative, so you can add in any order that you'd like. So here we have 9 minus 3, minus 8, minus 12, minus 4. So let me go equals 9, the leftmost number, not going to mess with that. So I'm just going to copy that. And then everything else, you're going to go plus negative. So this will be plus -3, and then plus -8, and then plus -12, and then plus -4. So now what I'm going to do is I'm going to add all these numbers over here because they're all negative first, right? So I'm just going to keep 9, and then I'm going to say negative plus negative plus negative plus negative is going to be a negative. And then just add the absolute values. So 3 plus 8 is 11, 11 plus 12 is 23, and then 23 plus 4 is 27. So this would be negative 27 here. And I should probably show that in case you were not using a calculator. So let me do that real quick. So 3, 8, you have 12, and then you have 4. Really quickly, 2 plus 3 is 5, 5 plus 8 is 13, 13 plus 4 is 17, so put a 7 down, carry the 1, 1 plus 1 is 2. So this is 27, that's where I got that from. I know some of you are not using a calculator, and you're just getting up to speed with addition. So now we have 9 plus negative 27, so this right here would be a negative because the sign of the number with the larger absolute value is negative, and then you're going to subtract the larger absolute value, which is 27, minus the smaller, which is 9. So let's do that off to the side. So 27 minus 9, borrow here. This is a 1. This is a 17. 17 minus 9 is 8. Bring down the 1. So this is going to be 18. So we'd have negative 18 as the answer. Okay, let's do another one. So here we have negative 2 minus a negative 3 minus a negative 9 minus 14. So negative 2, don't mess with that. Minus a negative is plus a positive. Minus a negative is plus a positive. And then you have minus 14, that's plus negative 14. Okay, so I'm going to reorder this and put negative 2 next to negative 14. Those have a common sign. And then I'm going to put 3 and 9 together. And then basically negative plus negative is negative. 2 plus 14 is 16. And then plus 3 plus 9 is 12. So now we know the answer would be negative because negative 16 has a larger absolute value. And you're just going to do 16 minus 12. I don't think you need a vertical subtraction for that. It's just going to be 4. So this would end up being a negative 4 as the answer. Okay, let's just do one more. So here, we have negative 5 minus a negative 17, minus 8, minus 9, minus a negative 4. So negative 5, don't mess with that. And then minus a negative is plus a positive. And then we're subtracting away 8, so that's plus negative 8. We're subtracting away 9, so that's plus negative 9. And then minus a negative is plus a positive. Okay, so I'm going to rearrange this and say that we have 17 plus 4, and then plus negative 5, and then plus negative 8, and then plus negative 9. So 17 plus 4, again, if you need to, you can just do a vertical addition. 7 plus 4 is 11. 1 down, carry the 1. 1 plus 1 is 2. So that's going to be 21. And then for this one, negative plus negative is a negative. And then we'll think about 5 plus 8, that's 13. And then plus 9, let's just do that off to the side. 3 plus 9 is going to be 12. 2 down, carry the 1. 1 plus 1 is 2. So that would be negative 22. I think we can all see that 21 plus negative 22 would be negative 1. But again, to go with the official procedure, we know that this would be negative because negative 22 has a larger absolute value. And so then you would just do the larger absolute value, which is 22, minus the smaller, which is 21. And so this is going to be the negative of 22 minus 21 is 1. So basically negative 1 for the final answer. All right, let's take a look at an alternative way to think about why subtracting away a negative becomes adding a positive. We saw this with a pattern. I'm going to give you one other approach to use. There are many available. Some people will show this as taking away a debt. Some people, instead of using a horizontal number line like I'm going to use here, you'll see a vertical number line, and maybe they'll use something like temperatures, so a positive and a negative temperature. Again, lots of different ways to think about this. So we're not going to actually do a number line subtraction if that's what you're thinking. What I'm going to do is think about the distance between 2 points on a number line. So let's start out with point A, and that's going to refer to 4. Let me highlight this as I go. So point A refers to 4 on the number line, and point B refers to 1 on the number line. Okay, so if I ask you for the distance between those 2 points, what am I asking for? Well, if I go from B to A, or from A to B, how far do I need to travel? And remember, when we think about distance, like we talked about in the lesson on absolute value, it's non-negative. So it's either 0, meaning I get in my car and I don't go anywhere, or it's some positive value. So I go somewhere. If A is your house and B is the coffee shop, well, if I go from A to B, so from my house to the coffee shop, let's say that's 3 miles. On the return trip, when I go from B to A and I'm going back, well, my car's odometer doesn't say, okay, this is negative 3 miles because we're on a return trip. No, I go 3 miles there and I come 3 miles back. So the distance is 3 either way. So that's why you see this set up like that. So we can show this as the distance between A and B as being equal to 3. Now, what's another way to do this? Your book will give you a subtraction formula that involves the absolute value. I'm going to keep this simple, and I'm just going to say that we're going to subtract the larger number minus the smaller, just for the sake of this lesson, to keep it simple. So I'm going to say this could also be 4 minus 1, which would give us 3. So I can do it with subtraction, larger minus smaller, or I can go through and manually count, either going from B to A, 1, 2, 3, or from A to B, 1, 2, 3. Again, don't worry about the direction. It's just how far am I traveling. So we can see that the distance between A and B on this number line can be found as 4 minus 1, which is going to give us 3. So let's go into something we already looked at. So what about 4 minus a negative 3, which becomes 4 plus 3, which equals 7? We're going to show this using the distance between these 2 points. Now, instead of this point B being at 1, it's going to be at negative 3. Point A will still be at 4. So let me highlight this, and then this, and this. So let's think about the formula we just had. The distance between A and B, we saw a moment ago, we had 4 and then we had 1, so we did 4 minus 1, larger minus smaller. So now what I'm going to do is 4 minus a negative 3. So again, larger minus smaller. We know that negative 3 is smaller than 4 because negative 3 lies to the left of 4 on the number line. So this right here, if I went through and counted, starting from 4, well, I would go 1, 2, 3, 4. So at 0, I've traveled 4 units. And then to get to negative 3, I've got to go another 1, 2, 3 units. Okay, so that means that this distance right here is 4. So from right here to right here. And then this distance right here is 3. So from right here to right here. So I basically take that starting number, which is 4, and then I'm going to add on another 3. So how could I look at that and get that? Well, I need this part right here, which is the 4, and then I need to add the opposite of whatever this negative number is to get this plus 3, or to tack on an additional 3 to get the total distance. So this statement, 4 minus a negative 3, becomes 4 plus 3, which becomes 7 as the answer. Now, looking at another one, let's say that we had point A. Now that's going to be at negative 1. So A, that point is at negative 1. Point B will now be at negative 6. Well, I can still use the same strategy. So the distance between A and B would be what? Take the larger number. In this case, it's negative 1. Negative 1 is to the right of negative 6, so it's the larger number. And then minus a negative 6. So I'm just subtracting the larger minus the smaller. So this should give me the distance between these 2 points. So looking at this and just counting, I can see that if I go from B to A or A to B, it doesn't matter. 1, 2, 3, 4, 5. That's my expectation. So I should get a 5 here. But how do I go from negative 1 minus a negative 6 to 5? Well, I'm going to have to change this minus a negative to plus a positive. So we'd have negative 1 plus 6, which would give us 5. Hello and welcome to Pre-Algebra Lesson 21. In this video, we're going to learn about multiplying and dividing integers. For the lesson objectives for today, we're going to learn how to multiply integers, and we're also going to learn how to divide integers. All right, so at this point in the course, we should know how to multiply whole numbers together. And we know that unless we have a factor of 0, if we multiply 2 whole numbers together, we're going to get a positive product. So I have here, we all know that the product of 2 positive numbers is positive, even if you've never thought about it. So we have that a positive times a positive will give us a positive. All right, so now let's build up to the rules where we're going to multiply with negative numbers. So first we have 4 times 3. So from the multiplication tables, we know the answer is 12. But going back to earlier in the course, we said that multiplication was a shortcut for repeated addition. So really I could write this as 3 plus 3 plus 3 plus 3. So I have 1, 2, 3, 4 of these guys. And so of course I could add 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12. So I get 12 either from this guy or from the multiplication tables and going with this guy. So we see that it's just a shortcut for repeated addition. Now what if I throw something in the mix like 4 times negative 3? Well, what does this mean? Again, if I follow this same thought process, well, it means that I have a repeated addition here where I have negative 3 plus negative 3 plus negative 3 plus negative 3 one more time. Well, we know how to add integers already, and basically we have a common sign, so we'll just put a negative right there, and then you could just add the absolute values. So 3 plus 3 plus 3 plus 3 is going to be 12. So the answer here becomes negative 12. Does this make sense? Just stop for a moment and think about it. Let's say that you are losing $3 a day at your business or whatever you're doing. So day 1, day 2, day 3, day 4, instead of adding those guys together, you could do a quick multiplication and say, okay, well, there's 4 days where I lost $3 each day. I would do 4 times 3 in my head and say that's 12, and then I would apply a negative to it because it's a loss. So that's basically what we're going to be doing when we multiply integers. Okay, we're going to think about the absolute values being multiplied, and then we're going to attach the sign that we need to. All right, now I want to show you something else because it's a little bit confusing when we go to -3 times 4. Okay, the way I like to show this is using my commutative property. So let me erase this real quick. We already know that 4 times 3 is equal to 3 times 4. So we can legally switch the order of the factors. If I think about 3 times 4, let me write that out. So 3 times 4, this is what? This is now going to be 4 plus 4 plus 4, which is also going to give me 12, right? So 4 plus 4 is 8, 8 plus 4 is 12. So if I get something like, let's say, -3 times 4, I can legally switch the order and say that this is 4 times -3, and I'm right back to this definition right here, which gives me -12. So we can see that a positive times a negative gives me a negative, and a negative times a positive gives me a negative. Let's go through the same thing with this guy right here. I'm just going to slide down a little bit. So we have 5 times 2. So let's start out with what we know. This is 2 plus 2 plus 2 plus 2 plus 2. So I have 1, 2, 3, 4, 5 of these guys. And so we know that 5 times 2 from the multiplication tables would be 10. But again, you could add 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. So we can also do 5 times -2 in a similar way. So this would be -2 plus -2 plus -2 plus -2 plus -2. And of course, this would be -10. Now, if I change the order, let's say I was given -2 times 5, well, of course, I could just flip it back, right? So it's going to give me the same answer because of the commutative property of multiplication. So I can just legally say that this is the same as 5 times -2, which would give me this -10. And if you were presented with, let's say, -5 times 2, well, you could flip that around into 2 times -5, and you could say that this is equal to what? This is -5 plus -5, which would be -10 as well. Okay, so let's look at the sign rules here. So we saw that a positive times a negative or a negative times a positive is going to give us a negative. So that's pretty easy to understand. Where we start running into problems is where you get negative times negative, and we say that's a positive. All right, let's quickly think about this pattern to show that a negative times a negative is a positive. There's other ways you can show this, but I think this is the quickest way and the easiest way to think about it. So if you have 3 times -3, we say that's -9. So we know that already, that 3 times -3 can be written as -3 plus -3 plus another -3. And of course, that is -9. Now, looking at this pattern, as we decrease this factor on the left by 1, so in other words, now this is going to be a 2, what's going to happen is the product here is going to increase by 3. So this 2 times -3 is equal to now only -3 plus -3. And so this would give me a -6. So I've increased by 3. Now, if I go to 1 times -3, I'm increasing by 3 again, right? So this is -3. And the pattern just continues. So now this goes to 0 and this goes to 0. So I'm increasing by 3. Let me actually get rid of this. And I'm just going to show this as this going plus 3. And this going plus 3. And this going plus 3. So when you get here to -1 times -3, again, this is just decreasing by 1. So from 0, if I subtract away 1, I'm at -1. And this is still increasing by 3. So plus 3. This goes down by 1. This increases by 3. So plus 3 and then plus 3. So -1 times -3, again, using this pattern would be positive 3. Then -2 times -3, using this pattern, would be positive 6. And then -3 times -3, using this pattern, would be positive 9. All right, so once you have the sign rules down, you're ready to multiply integers. And basically, if you can multiply whole numbers, then you could just blow through these problems. The first thing is you want to determine the sign of the product. So if you have a positive times a positive or a negative times a negative, so if you have the same signs, your answer or your product will be positive. And then if you have different signs, so a negative times a positive or a positive times a negative, your answer will be negative. So you have a negative product in that situation. So once you figure out what the sign is, you just want to multiply the absolute values. So it's really, really quick. So let's come through here and just blow through some of these problems. You have a -2 times 7. negative times positive is negative. Again, different signs. Then just multiply 2 times 7, that's 14. So the answer is negative 14. Here we have 4 times negative 4. So you have a positive times a negative, that's a negative. So different signs, negative product. Then 4 times 4, just multiply the absolute values, that's 16. So the answer is negative 16. Here we have negative 11 times 5. So you have a negative times a positive, that's a negative. And then 11 times 5, that's 55. So this is negative 55. Here we have negative 12 times negative 9. So a negative times a negative is a positive. So when you first start doing this, you can write out a plus symbol if you want. Of course, it's not necessary. So I'm just going to do it just for the sake of completeness here. Now, I want to do 12 times 9. Some of you are still learning how to multiply. So I'll do that as a vertical multiplication. So 9 times 2 is 18. 8 down, carry the 1. 9 times 1 is 9, plus 1 is 10. So this is 108. So this is positive 108. Of course, you can keep the plus sign out there if you want, or you can just write 108. But negative times negative is positive, and also positive times positive is positive. So if you have the same sign, negative and negative, then basically you're going to have a positive product. Okay, here we have negative 10 times negative 4. So we know this is a positive. Again, you can put a plus sign out there or leave it off. It's up to you. And then if we're multiplying 4 times 10, right, you're multiplying the absolute values there. Well, you just multiply 4 times 1, that's 4. And then just attach one trailing 0. So this would be positive 40. Then here, a negative times a negative, again, is a positive. And then you're doing 15 times 14. Let me do that over here. So 15 times 14. 4 times 5 is 20. 0 down, carry the 2. And then 4 times 1 is 4, plus 2 is 6. And then let me erase this. 1 times 15 is 15. But remember, you're starting in the tens place here, so you've got to move this over. So you're going to put a 5 here and a 1 here. And then let me just add this. So bring down the 0. 6 plus 5 is 11. 1 down, carry the 1. 1 plus 1 is 2. So this would be 210. So this would be 210. All right, now let's talk about what happens if we multiply more than 2 integers. So this is just as easy. First, let me do this the long way, and then we'll think about what's going on. So let's say I work left to right, and I go negative 6 times 1, and that's going to give me negative 6. Negative times positive is negative. 6 times 1 is 6, so that's negative 6. So let me copy this. So times negative 8, and then times negative 4. So now you have a negative 6 times a negative 8. Negative times negative is positive, and then 6 times 8 would be 48. So this is positive 48, and then times negative 4. So here, positive times negative is negative, and then 48 times 4, some of you can do that in your head. It's going to be 192, but just in case you can't, 4 times 8 is 32, 2 down, carry the 3. 4 times 4 is 16, plus 3 is 19. So bring this over here. The final answer is negative 192. Now, an easier way to do this is to count the total number of negative factors. Now, if the total number of negative factors is going to be an even number, and I'll explain what that is in a moment, then you're going to have a positive product. If the total number of negative factors is an odd number, I'll explain what that is in a moment, then you're going to have a negative product. Let me actually erase this real quick. And I'm just going to put this up here. This is negative 192. I want you to see what would happen if I wrote negative 6 times negative 1 times negative 8 and then times negative 4. How would that change the product from this guy going to this guy? Well, what's happening is, in this particular case, notice that you have these two guys that you can pair up, and then you have this one left over. So basically you have 3 negative factors, and 3 is an odd number. Again, I'll explain what that is in a moment. So this guy right here gives me a negative product. But this guy, I have these two that I can pair up, and these two that I can pair up. So basically, each pair creates a positive, right? Each pair of negatives. So negative times negative gives me a positive, and then negative times negative gives me a positive. So because I have 1, 2, 3, 4 negative factors, and 4 is an even number, this is going to be a positive product. So this would change this to positive 192. Now, when I say even and odd, what do I mean? We haven't gotten to what we call the divisibility rules yet, but basically, if you can divide a number by 2 and there's no remainder, so something like 2 divided by 2 is 1, 4 divided by 2 is 2, 6 divided by 2 is 3, so on and so forth, well, that's an even number, right? You can basically pair things up. So if I had, let's say, negative 6 times negative 1 times negative 8 times negative 4, and let's say I tacked on times negative 1 and then times negative 1, well, here's a pair, here's a pair, here's a pair. I have 6 negative factors, so that means I'm going to be able to pair these negatives up, and there's nothing left over, and so I'm going to end up with a positive result. So this would still be positive 192. Now, if I took one of these away, like this, Well, now the answer is going to change into negative 192 because I can pair these guys up and pair these guys up, but this is a leftover. So that means that an odd number would be something that's not divisible by 2. So in this case, you have 1, 2, 3, 4, 5 of these guys. If I take that 5 and I divide it by 2, what's going to happen is I'm going to get 2 with a remainder of 1. So you have 1, 2, and then 1 left over. That 1 left over, or that remainder, is always going to give you a negative because I can't pair it with another one. If I go back to times negative 1, well, now I can pair it up. I have 6 of these guys. 6 divided by 2 would be 3, right? 1, 2, 3 of those guys. So this would give me a positive 192. Let's fly through this now. So we have negative 8 times 3 times negative 2 times 11. Okay, so I have 1, 2 negative factors. 2 is an even number. 2 divided by 2 is 1, no remainder. And so I know I'm going to have a positive product. So now I can just multiply absolute values. 8 times 3 is 24. 24 times 2 is 48. So I need to know what is 48 times 11 now. And so 1 times 48 is 48. And then this one, again, you've got to move down. 1 times 48 would be 48. And let's add here. So 8 comes down. 4 plus 8 is 12. 2 down, carry the 1. 1 plus 4 is 5. So let's drag that up there and say the final answer is 528. Okay, let's take a look at one more. So here we have negative 2 times 5 times negative 1 times 3 times negative 20 times negative 30. So this looks a lot worse than it is. First, again, I would count. I have 1, 2, 3, 4 negative factors. 4 is an even number, right? 4 divided by 2 is 2, no remainder. Again, you can always pair these guys up. So this guy and this guy, that's going to make a positive. And then this guy and this guy, that's going to make a positive. So if you have an even number of negative factors, you will get a positive result. So here I can just go through and multiply the absolute values. So 2 times 5 is 10. And then times 1 would still be 10. And then times 3 would be 30. Let me stop and write this out. So I have 30. And then forget about the signs here. We already know it's positive. Times 20 and then times 30. Okay. Well, what I can do is use my trick for trailing zeros. 3 times 2 times 3. 3 times 2 is 6. 6 times 3 is 18. So this is 18. And then I have 1, 2, 3 zeros that I'm going to attach to the end. So 1, 2, 3. So the final answer here would be positive 18,000. All right, now let's move on and talk about dividing integers. So this is just as easy as multiplying integers. So the first thing is we want to determine the sign of the quotient. And then once we've done that, we just want to divide the absolute values. So the sign rules are pretty easy. So basically, if you're dividing integers and you have the same sign, you're going to get a positive quotient. If you're dividing integers and you have different signs, you're going to have a negative quotient. So positive divided by positive or negative divided by negative will give you a positive. And then if you have a positive divided by a negative or a negative divided by a positive, you will get a negative. All right, before we get to the problems, let me take a few minutes here and think about where the sign rules come from. So let's start out with something we know. Let's say we have 15 divided by 3. So again, what does this mean? It means I have 15 of something, could be boxes, could be whatever, and I'm going to split it up into equal groups where each group has 3. So 3 boxes or again, whatever you have. So we can use a related multiplication statement, or again, you can use repeated subtraction. So you could go through and say, okay, this is 15 minus 3, and that would give you 12. And then you can go 12 minus 3, and that would give you 9. And then you would go 9 minus 3, and that would give you 6. And then 6 minus 3 would give you 3. And then 3 minus 3 would give you 0. So I did that 1, 2, 3, 4, 5 times. So the answer is 5. And of course, we already know that. So the answer here would be 5. Or you could have asked the question, what times 3 gives me 15, and the answer from the multiplication tables would be 5. So we know 5 times 3 is 15, so 15 divided by 3 is 5. Okay, so using that same logic, let's go ahead and ask the question, what is negative 15 divided by 3? Well, this would be what? I would put a question mark here and just say, well, question mark times 3 would give me negative 15. Well, for multiplying integers, we know that if this is negative, well, that's going to come from a positive times a negative or a negative times a positive. This right here is positive, so this has to be negative. So the question mark would be a negative. And then, of course, multiplying the absolute values, we know that 5 times 3 would give us 15. So this would be negative 5 here. So the question mark here would be negative 5. Okay, so that's one way to think about it. I have some things set up over here. So now we're doing 15 divided by negative 3 equals what? Well, again, what times negative 3 would be 15? Well, this right here would have to be a negative 5 now, because negative times negative would be positive. So negative 5 times negative 3 would be positive 15. So that means 15 divided by negative 3 would be negative 5. Now coming through here, negative 14 divided by negative 7 is what? Again, you could say what times negative 7 is equal to negative 14. So here you would want a positive, right? Because positive times negative is negative. So this would be a 2. 2 times negative 7 is negative 14. So negative 14 divided by negative 7 is positive 2. So here we have that a positive divided by a positive gives you a positive. You have a negative divided by a negative gives you a positive. So again, same signs, you get a positive quotient. Then you have a positive divided by a negative gives you a negative, and then a negative divided by a positive gives you a negative. So different signs, negative quotient. Okay, let's burn through some examples. So you have negative 50 divided by 5. So again, negative divided by positive is negative, and then 50 divided by 5 would be 10. So this is negative 10. Here you have negative 40 divided by 4. So negative divided by positive is negative. 40 divided by 4 is 10, so this is negative 10 as well. So then we have negative 200 divided by negative 10. So negative divided by negative is positive, and then 200 divided by 10 is 20. And then coming down here, you have negative 34 divided by negative 17. Negative divided by negative is positive. 34 divided by 17 is 2. Then we have 27 divided by negative 3. So positive divided by negative is negative. 27 divided by 3 is 9, so this is negative 9. And then for the last problem, we have 16 divided by negative 4. Positive divided by negative is negative. And then 16 divided by 4 is 4. So this is negative 4.
Hello and welcome to Pre-Algebra Lesson 22. In this video, we're going to learn about exponents with an integer base. So for our lesson objective, we want to learn how to perform operations with exponents that have an integer base. So before we get into the main content, let's just briefly review exponents. So recall that at this stage, we're using exponents to conveniently notate repeated multiplication of the same number. So for example, something like 3 times 3 times 3 times 3 times 3. I have 1, 2, 3, 4, 5 factors of 3, so I can write this as 3 to the 5th power. Right? The number that's being multiplied by itself gets written as the bigger number. This is known as the base. Okay, so that's 3 in this case. The smaller number in the top right-hand corner, this 5, is the exponent. Okay, it's the exponent. And so it's telling me that I have 5 factors of 3. Now, if we want to look at another example, let's say we had 7 times 7 times 7. The number that's being multiplied by itself is 7. So that's my base. That is my base. And then I have 1, 2, 3 factors of 7. So my exponent is a 3. So at this point, it's very, very easy to work with exponents. We've only worked with a base that's positive. What we're going to think about today is what happens when we have a negative base. Well, when we're working with exponents, we need to be extra cautious when dealing with negative numbers. There's some notational issues that are going to come up, and we're going to explain that in this video. So when working with a negative number that is raised to a power, the base does not include the negative part unless we use parentheses. Okay? So let me read this again. It's very important that you understand this. When working with a negative number that is raised to a power, the base does not include the negative part unless we use parentheses. So let's think about this problem using an example. I want you to pretend that your teacher tells you, hey, what is negative 2 squared? So you have your pencil, your paper, and you have a calculator. And you start out by writing negative 2 squared, just like that, no parentheses. And you go through, and from your knowledge of exponents, you say, okay, I have 2 factors of negative 2. So I have negative 2 times negative 2. Now you say, okay, negative 2 times negative 2 is 4. Now you pull out your calculator and you verify. You say, okay, I'm going to type in negative 2. I'm going to use the to the key, right? The to the key. And then I'm going to put a 2 in. So it's negative 2 to the power of 2. And I'll just erase that real quick and write it like this. And your calculator spits out an answer that says negative 4. And so you're thinking, what gives? Why did my calculator say that this is negative 4, whereas I think the answer is positive 4? Well, I'm going to tell you it's a notational issue. And here's why. So let me kind of erase this. This is wrong, by the way. So I'll erase this and show you why. All right, if I have negative 2 squared written like that, really what I'm saying is I want the opposite of 2 squared. So to make this clear, let me write this as negative 1 times 2 squared. And using our order of operations, we know that we would perform any exponent operation before we multiply. So essentially, I would have negative 1 times the result of this. 2 squared is 2 times 2, that's 4. So now I have negative 1 times 4, and that's negative 4. So you can see where we got the wrong answer, right? We just didn't have the right notation. So to get the notation correct for what your teacher asked you for, if your teacher said, hey, what is negative 2 squared? Well, essentially, I would need to put parentheses around negative 2. The negative and the 2 need to be enclosed so that they are both part of the base. So this now is a negative 2, and I'm squaring that. So this would be equal to negative 2 times negative 2. And this is now equal to 4. And you can verify this. Go ahead and type this in this way with your calculator. Make sure to put parentheses around the negative 2, and you will see that you get an answer of 4. Now you might be saying, what if I did this trick up here where I'm multiplying by negative 1? Well, it still works out. Let's say I did negative 1 times 2 enclosed in a set of parentheses, and I squared it. Well, essentially what's going to happen is I'd have what? Negative 1 times 2 multiplied by negative 1 times 2. And just to kind of simplify this, I just have multiplication involved. So I can just remove all those parentheses and just write this as negative 1 times 2 times negative 1 times 2. And commutative property tells me I can reorder this. So I'd have negative 1 times negative 1 times 2 times 2. So negative 1 times negative 1 is positive 1. Then positive 1 times 2 is 2. 2 times 2 is now 4. So we can see that our mistake was just with the notation, right? That's all it is. So moving forward, the only thing we need to realize is that if I have a negative number that I'm working with, and I want to raise it to a power, I have to enclose that negative number inside of a set of parentheses. Now, there are some scenarios where you'll get the same result, although the notation is wrong. And let me show you one of those. So let's say you had something like negative 4 to the third power written like this. The negative 4 is not inside of a set of parentheses. So technically speaking, because of the notation, this is the opposite, or you could say the negative of 4 cubed. I could write this as negative 1 times 4 cubed. And of course, following my order of operations, I would do 4 cubed first. That's 4 times 4, which is 16, times 4 again, which is 64. So this is negative 1 times 64, which is negative 64. Now, let's suppose that I enclosed this negative 4 inside of a set of parentheses. In the last situation we looked at, we went from negative to positive, right? We kind of corrected our mistake and we got a different answer. Will we still get a negative or will we get a positive here? Well, what you're going to find is that in this case, it will not change your answer. And then we're going to explain why that's the case. So let's say I enclose this inside of a set of parentheses. So now I have negative 4 times negative 4 times negative 4. Well, I have 3 negatives involved in this problem. 3 negatives is going to give me a negative. 3 is an odd number. In other words, I have one pair here of negatives that gives me a positive, but then I have one left over, right? So I'm going to end up with a negative result. So I would have a negative 64 in this case also. Now, knowing that, I'm going to go through and read some rules that you just want to remember when you're working with exponents. When the base is negative and enclosed in parentheses, the result is positive if the exponent is even, right? Because I would have an even number of negative factors. That gives me a positive result. The result is going to be negative if the exponent is odd, because I would have an odd number of negative factors. That's going to give me a negative result. And then the other scenario you need to be aware of is that when the base is negative and not enclosed in parentheses, the result is always negative. Always negative. Doesn't matter what the exponent is, because in that scenario, you're just saying, hey, I want the opposite of what you're doing over there. So, for example, the opposite of 4 squared. Because this negative 4 is not inside of a set of parentheses, this will always be negative, right? This will always be negative. So in this case, it would just be the opposite or the negative of 4 squared. 4 squared is 16, so this would be negative 16. If I was to write this with negative 4 inside of a set of parentheses, now I would get positive 16. Because in this case, I have negative 4 times negative 4. Two negative factors gives me a positive result. So in this case, I'm thinking about, okay, well, my exponent is even. I'm going to get a positive result. Okay, let's use these rules and just do some practice. So we want to evaluate each. All right, so we have negative 3 inside of a set of parentheses, and it's squared. So this tells me that I have what? I have negative 3 times negative 3. So this is going to be positive 9. But again, what I can do is I can just look at, because this is inside of a set of parentheses and my exponent is even, I know my answer is going to be positive, right? I have an even number of negative factors. In this case, it's 2. And an even number of negative factors gives me a positive result. What about negative 3 raised to the 5th power? And notice how the negative 3 is enclosed inside of a set of parentheses. Well, I know the result is negative because I have an odd exponent there. 5 is an odd number. And so I would have an odd number of negative factors. And you can just think about 3 to the 5th power now. You don't even need to think about the sign anymore. 3 to the 5th power would be what? It'd be 3 times 3, that's 9. Times 3 again, that's 27. Times 3 again, that's 81. Times 3 one last time, which would be 243. So this would be negative 243. What about negative 1 to the 38th power? Well, 38 is an even number. So we know the answer is going to be positive. Now what's cool about the number 1 is when you multiply it by something, the number is unchanged. If I multiply 1 by itself, it doesn't change. So 1 times 1 is 1. Doesn't matter how many times I do that. If I go 1 times 1 times 1 times 1 times 1 times 1, the answer is 1. I could do this a million times, I still get 1. So 1 to the 38th power, forget about the negative. 1 to the 38th power would just be 1. The fact that we have a negative and it's enclosed inside of a set of parentheses tells me I just need to look at whether this exponent is even, which in this case it is, or odd. Since it's even, I know I'd have an even number of negative factors, and an even number of negative factors gives me a positive, so I end up with positive 1. What about negative 1 to the power of 71? Well, my negative 1 is enclosed inside of a set of parentheses, but my exponent is odd. So I would have an odd number of negative factors. Now that would give me a negative result. And I would just think about 1 to the 71st power is just 1. So I'd end up with negative 1 as my answer. Okay, now we have negative 10 cubed, and this negative 10 is inside of a set of parentheses. So again, I'm looking at this exponent. This exponent is a 3. That's an odd number, and so that tells me I'm going to have a negative result. Once I know the sign, I can just think about, okay, well, what would 10 cubed be? What would 10 cubed be? Well, I taught you a trick for this. Basically, when you have 10 raised to a whole number that is larger than 1, you just write down a 1 and follow it with the exponent number of zeros. So in this case, the exponent is a 3. So I would write 1, 2, 3 zeros, and I would get 1,000. You can just drag that up there and attach that negative to it. And you would end up with negative 1,000 as your answer. What about negative 8 squared? But again, notice how there's no parentheses around negative 8. So I'm not looking at the exponent here. I don't care that this exponent is even. The result is going to be negative, right? Because I'm basically saying, hey, what's the opposite of 8 squared? 8 squared is 64. When I take the opposite of it, I get negative 64. Right? And let me kind of write this out so you get a little bit more practice seeing this. So this is essentially negative 1 times 8 squared. So it's negative 1 times 64, which equals negative 64. Now what about negative 8 squared, where the negative 8 is enclosed inside of a set of parentheses? Well, now I'm looking at my exponent. I have a 2 there. 2 is an even number, so I know my answer is going to be positive. And now I can just think about, well, what is 8 squared? Okay, well, that's 64. And so my answer would just be 64. Okay, let's take a look at negative 5 cubed, where the negative 5 is enclosed inside of a set of parentheses. Well, in this case, my exponent is odd, so I'm going to get a negative result, right? An odd number of negative factors gives me a negative. And now I just think about, well, what is 5 cubed? 5 cubed is 5 times 5, that's 25. Then times 5 again, that's 125. So my answer is negative 125. For the final problem, we look at negative 5 cubed, where there's no parentheses around the negative 5. Now in this case, we also get a negative 125. And you might say, well, how come I got the same answer? Again, to explain this, in this case, I'm saying, hey, what's the opposite of 5 cubed? 5 cubed is 125. The opposite of that is negative 125. In this case, whether the exponent is odd or even, it doesn't matter. You always get a negative. And looking at this scenario, where I have parentheses around negative 5, I look at my exponent. If my exponent is odd, like it is in this case, I'm going to get a negative result. I would have had negative 5 times negative 5 times negative 5. Right? I have 3 negative factors. 3 is an odd number, so I'm going to get a negative result.
Hello and welcome to Pre-Algebra Lesson 23. In this video, we're going to talk about the order of operations with integers. So the lesson objective for today would be to learn how to use the order of operations when integers are involved. Now, we previously talked about the order of operations when we wrapped up our section on the whole numbers. So now that we're wrapping up our section on the integers, we're going to revisit this topic and just do some examples with integers involved. So before I go through the order of operations, I just want to remind you, if you're using something like PEMDAS, so this is really popular in the United States. In other countries, you might hear BODMAS. It's basically telling you the same thing. You need to be really careful. A lot of people remember this as please excuse my dear Aunt Sally. So parentheses, exponents, multiplication, division, addition, and then subtraction. Remember, when you look at this, the M and the D, the multiplication and division, have the same priority level and they need to be worked left to right. I can't tell you how many times people memorize this and then they're looking at that and they're saying, okay, I need to multiply before I divide. They are on the same priority level. They are worked left to right. Then the other guy here is addition and subtraction. So same priority level. They're worked left to right. So if we go through this, we would say the first thing is to work inside of any grouping symbols. So that's why we have that P that stands for parentheses, but it's also for brackets or absolute value bars or anything that's a grouping symbol. The second thing would be to perform all exponent operations. So that's the E there. Now included in this would be something like a square root. So let's say you had something like the square root of 4. And we haven't talked about this yet in the course, and I'll explain as we get to an example, but actually we can convert this over to exponential form. So this is actually 4 to the 1/2 power. So if you have a square root involved or a cube root or something like that, you would actually do this on the same level. So I'll talk more about this as we get into a problem. Let's just erase it for now. So coming down here, you'll see the third and the fourth steps. This is where people get lost, right? So again, if I write out the PEMDAS, so PEMDAS like this right here is where everybody gets confused. So the M and the D. I have here multiply or divide working left to right. So if multiplication comes before division, working left to right, you do multiplication first. If division comes before multiplication, again, working left to right, you do division first. Same priority level. Don't let this ordering of the letters here trip you up. Then the same thing is going to go for the A and the S. So add or subtract, again, working left to right. Okay, with that being said, let's just jump in and look at some problems. So we want to evaluate each. All right, so let's take a look at the first problem. We have -3 times, then you have -2, and notice this -2 is wrapped, and this is being squared, and then plus you have -24, and then divided by 4. So what is the highest priority? Again, we start with parentheses. The only parentheses we have would be this guy right here, which is wrapping this -2, and this guy right here, which is wrapping the -24. So there's nothing to really do there with parentheses. Then we move on to exponent operations. So do we have anything with an exponent? Yeah, we have this -2 that's being squared. So I want to stop here and remind you of what we talked about in the last lesson. If you have -2 and it's wrapped, so it's inside of parentheses, and I square it, this is equal to -2 and then times -2, which is +4. Okay, you can do this on your calculator. Make sure you wrap it. So you would wrap it like this, -2. You would hit that key there, and then you would put your 2 in there, and then basically you would get a 4 as an answer. Now this is different versus if I did this. Let's say I wrote -2 like this. I did not wrap it, and then I squared it like this. Let's say you key that into your calculator. You're going to get an answer of -4. And you're probably going to be confused by that because you're saying, well, that's -2 squared. it's a notational issue. If I ask you for -2 being squared, you want to use this, okay? This is basically going to get translated into -1 times 2 squared. So in other words, the base here is actually 2, right? It's not -2 because this negative is outside of here. You could read this as the negative of 2 being squared. Okay, so this would end up being -1 times 2 squared would be 2 times 2 or 4. So this is -4. So if you key it into your calculator, you've got to make sure that you use the right notation so that you get the right answer. So let me get rid of this. And what we're going to do is put equals here. And I'm just going to replace this with a +4. So we have -3 and then times +4. And then plus you have -24 and then divided by 4. So I've taken care of my exponents. The next thing again is multiplication or division working left to right. So here I see that I have multiplication and I have division. Now working left to right, this multiplication occurs to the left of this division. So that means this guy right here is the higher priority. Let me unhighlight that. So that means I'm going to do -3 times 4. So a negative times a positive is a negative. So let me write that's a negative. And now I can just say, well, what is 3 times 4? That's 12. So this would be -12 here. Okay, then we have plus -24. And then divided by 4. So now I'm still on my multiplication and division step, and I have division here. So I'm going to divide -24 by 4. So -24 divided by 4 would be -6. Negative divided by positive is negative, and 24 divided by 4 is 6. So that's -6. So we would say this is -12, and then basically we would have plus -6, or you could write -12 minus 6, whatever you're more comfortable with. So the last thing here is just to do this addition. So -12 plus -6, you have a common sign. Both of these guys are negative, so the answer would be negative. And then you could just add the absolute values. So 12 plus 6 is 18. So this gives me a final answer of -18. All right, now before we move on to the next problem, I'm going to do this problem in a different way. I'm actually going to change it up. So you see we got -18 there. So what I'm going to do is actually write this problem as -3, and then instead of wrapping this, I'm just going to put times the negative of 2 being squared like this, then plus, we're going to have -24, and then divided by 4. And I'm going to show you that you get a completely different answer. Now you're going to get +6, and the change is going to be because this guy right here is going to throw everything off because your sign is going to go from a +4 to a -4. So if you're keying this into your calculator, and you're expecting to get the same answer as this, I'm going to show you where you're going to run into an issue. So let me copy this and let me paste this in. I'm just going to run through this really quickly. So we know the first thing we would do would be the exponent operations. But again, because this is the negative of 2 being squared, this becomes -1 times 2 squared in your calculator. 2 squared is done first because of the order of operations. So that's 4. So you get -1 times 4, which is -4. Okay, it's only +4 if this gets wrapped. So I'm going to replace this right here with a -4. So you'd have -3 times -4, then plus -24 divided by 4. So now, just like we saw before, we're going to do this multiplication first, but now instead of a negative times a positive, we have a negative times a negative. So a negative times a negative is a positive. So -3 times -4 would be +12. Now we have our plus -24 and then divided by 4. So now we would do our division. So -24 divided by 4, that's going to be -6. So this becomes 12 and then plus your -6, or you could go 12 minus 6 if you want. And obviously the answer there is 6. So you see the other way we did it, when we wrap this, we got a -18. And when we don't wrap this, we get a +6. So it's very important to understand this notational issue. It's going to come up for the rest of your time that you're studying math. All right, let's take a look at the next problem. So here, another easy one. We have -20 divided by -5, then -12 times 2 plus 3 squared. Now, the first thing we want to do is work inside of parentheses or any grouping symbols. So we do have parentheses here, but they're just used for clarity, right? They're just used to wrap that -5. So you can ignore that here and just move into working with the exponents. So here we have 3 squared, so we'd want to do that first. So this is the highest priority. Let me copy all of this. So -20 divided by, you can wrap this or not wrap it. I'm just going to wrap it for clarity. So divided by -5, then -12, and then times 2, and then plus. So 3 squared is 3 times 3. That's going to be 9. So we've taken care of the exponents. And now we want to move into the multiplication or division. So let me write this one more time, because people do get lost here, and it's very important to understand that multiplication and division occur on the same level. Okay, they're work left to right. So if you're using PEMDAS, or please excuse my dear Aunt Sally, or you're in a different country than me and you're using BODMAS, it's the same thing. You want to highlight these two and say that they are worked left to right. Okay, might want to put that down in your notes or something like that. It's very important to remember that. Let me erase this, and we're going to think about this. I have division right here, and then I have multiplication right there. Which one am I going to do first? Again, they're the same priority level. So I want to work left to right. So starting on the left, this operation occurs before this one. Okay, so that means I'm going to do my division first. So I'm going to divide negative 20 by negative 5. So negative divided by negative is a positive, and then 20 divided by 5 would be 4. Okay, so that's done. Then we have minus 12 times 2 plus 9. Now, the next step, because we're still on the multiplication or division level, would be to multiply 12 times 2. Now, if you want, you can convert this over. You could say this is plus negative and do it that way, or you can keep it like this. It's going to give you the same answer in the end. It's really up to you. So I'm just going to keep it like this. So I'm going to say this equals 12 times 2 is 24. So we would have 4 minus 24 and then plus 9. So here we have subtraction and we have addition. Now, when you have integers involved where you're dealing with positive and negative numbers, I like to convert all of the subtraction into a related addition problem. I think it just makes it easier. So I'm just going to go plus negative like this. And then because of the commutative property of addition, you can add in any order. Okay, so I can just say this is 4 plus negative 24. Maybe I could wrap that to make it more clear. And then plus 9. So I can add however I want. Typically what you'll do is you'll add the numbers with the same sign first. So I would say 4 plus 9 would be 13. And let me reorder that so nobody's lost. Let me reorder this to 4 plus 9 plus negative 24. 4 plus 9 would be 13. And now we have plus a negative 24. So now we want to do 13 plus a negative 24. So hopefully you have mastered adding integers at this point. I know when you have a different sign involved, it can be a little bit tricky for some people. But basically you want to look at these two numbers and say which number is larger in terms of absolute value. The absolute value of 13 is 13. The absolute value of negative 24 is 24. So negative 24 has a larger absolute value, so we're using that sign. So the result will be negative. So now I can just think about these numbers as if they were positive numbers, and I could just do a subtraction. Subtract the bigger minus the smaller. So what is 24? Let me do this off to the side. What is 24 minus 13? I think a lot of you can do that in your head at this point and say it's 11, but just in case you can't, 4 minus 3 is 1, and then 2 minus 1 is 1. So this is going to be 11. So this would be negative 11 for the answer. All right, let's take a look at the next problem. So this is a little bit more challenging, but still not that bad overall. So we have some brackets here, and inside the brackets, we have a set of parentheses, so negative 4 being squared, plus 52, that's inside the first set. Then plus inside the second set, you have negative 93 divided by 31, then plus 55. Then outside the brackets, we have divided by a set of parentheses here, which is 2 cubed minus 28 inside. All right. The first thing I want to do is work inside of any parentheses or grouping symbols. Well, you have brackets here, and then you have parentheses here. So what I'm going to do is actually start off inside the brackets. And when I do that, I want to reapply the order of operations. So in other words, I want to look for parentheses again, and let me change my highlighter color here. You see that you have that here, and then you have that here, okay? So you want to make sure that you do what's inside the parentheses here, and then what's inside of the parentheses here separately, and then you can add. So it doesn't really matter if you do this one first or this one first. I'm just going to work on the one that's here on the left first. Let me put a little border here, and I'm going to say I have a negative 4 being squared plus 52. So let's do that first. Now, like we previously talked about, if you're keying this into the calculator, make sure that you wrap negative 4 before you square it. Otherwise, you're going to get the wrong answer. Because if you have negative 4 being squared, this is what? This is negative 4 times negative 4, which is positive 16. If you have the negative of 4 squared, again, the negative is not wrapped. So this is really negative 1 times 4 squared, which gives you negative 16. Two different results in your calculator. So if you don't make sure that you're wrapping this, you're going to get the wrong answer. So very important. So when we look at this, we see that we have an exponent operation and we have addition. So we would do the exponent operation first. It has the higher priority. We just said that negative 4 squared was 16, and then we would add that to 52. Now, I can pretty much do that in my head. I know that's 68, but just in case you can't and you're not using a calculator, again, you can always stop and do a vertical addition. So 52 plus 16, 2 plus 6 is 8, 5 plus 1 is 6. So that's how we get the 68. Okay, so let's erase everything. And how much work you want to show is up to you. I'm just going to show all the steps so nobody's lost. I'm going to put the brackets here. The result of this is 68. Then plus, I'm just going to copy this. So you have negative 93 divided by 31 plus 55. So that's inside the parentheses. Close down the brackets, and then we're dividing by. So inside these parentheses, you have 2 cubed minus 28. Okay, close that down. Let me slide down here a little bit. All right, now the next thing is we're still working inside of the brackets. So now let's go into these parentheses here. And so basically you have negative 93 divided by 31 and then plus 55. So we would obviously divide before we add. Division has a higher priority level. Negative divided by positive is negative. When we think about 93 divided by 31, that one's a little bit tricky because essentially you can't really benefit from doing the long division. You really have to say, well, what is 93 divided by 31, right? Because 31 goes into 9 0 times. So you have to expand this and say, well, 31 goes into 93, so I'm back to the original division problem. If you use multiplication, you would find that it's 3. 31 times 1 is 31, 31 times 2 is 62, and then 31 times 3 would be 93. So you basically have to use multiplication there. So 3 times 31, as I just said, is 93. Subtract here, you get 0, so there's no remainder. So this would end up being negative 3, right? So negative 93 divided by 31 is negative 3. Okay, let's get rid of this, and now we're going to add 55. Now, this one, again, it's a little bit tricky because you're adding integers with different signs. What I like to do is flip the order here and say this is 55 plus a negative 3. And then notice, if I had been given 55 minus 3, I can legally go to that. We can always convert our subtraction into a related addition. So change the subtraction into addition, change the number being subtracted away into its opposite. Okay, so this ends up just becoming 55 minus 3, which is going to be 52. So let's get rid of this, and let's say this equals, inside of brackets, 68 plus 52, and we'll close that down, and it's divided by, again, in the parentheses, we have 2 cubed minus 28. Okay, let's wrap things up by doing this addition here. I think it's probably something, again, you could do in your head, but there is some carrying there, so maybe you want to write it out. So 68 plus 52, 8 plus 2 is going to be 10. Put a 0 down, carry the 1. 1 plus 6 is 7, plus 5 is 12. So this would be 120. And say this equals 120, so we're done with that, divided by, again, inside the parentheses, 2 cubed minus 28. So now I want to work inside of these parentheses here, and I want to do 2 cubed first. Let me make that a little bit more clear. I want to do that first because that has a higher priority than the subtraction. So 2 cubed is 2 times 2 times 2, which is going to be 8. So let's say this is 120 divided by, you would have 8 minus 28. So now I want to do the subtraction. Again, what I like to do is go plus negative here and think about it that way. So if I have a negative 28 plus 8, then I'm using the sign of the number. Let me write 120 here. I'm using the sign of the number with a larger absolute value. So negative 28 has a larger absolute value, so I'm going to put a negative there. And then I'm just going to do a subtraction. So basically the larger absolute value minus the smaller. So basically you would say that 28 minus 8 would be 20. So this is divided by negative 20. Okay, so from here, it's actually pretty easy. We know positive divided by negative is a negative. And then you can think about 120 divided by 20. So again, we have another one where the long division doesn't really help you that much because 20 doesn't go into 1 or 12. So you have to go all the way into what is 20 into 120, which is basically going to give us 6, right? You have to use a related multiplication statement to figure that out. So 6 times 20 is 120. Subtracting, you get 0. So this becomes negative 6 as our final answer. All right, let's take a look at the next example. So this one's a little bit more tedious, a little bit more time consuming is what I would really say. So we have the square root of 64 times negative 9. Let me wrap this here so it's more clear. Then you have minus a negative 3, then plus. Remember, these vertical bars tell you that you want the absolute value of something, and those are grouping symbols. So we have the negative of 2 squared. So notice this negative here is not wrapped inside of parentheses. Then times negative 15, and then plus 4, and then divided by 2. I'm going to wrap this also for clarity. And then down here we have minus, and then we have these parentheses here. So you have -2. Notice this one's wrapped, being squared, plus -8 divided by 2, and this is squared. The first thing I would do is think about what parentheses or grouping symbols do I have. When you have parentheses that are just used like these, just to wrap a number, don't worry about them. Okay, so you're just looking for grouping symbols like the absolute value bars there, or these parentheses here. Okay, so you have some operations inside. So where I want to start, let me get rid of this highlighting here so nobody's confused. Where I want to start, I'm just going to start inside of the absolute value bars. If you wanted to do this guy inside of here first, it's really up to you. I'm just going to start there. So I'm just going to copy this down here. So we have the absolute value of, again, be very careful. This is the negative of 2 squared times, I'm going to wrap this, so -15. Then plus 4, and then divided by 2. We'll come back up in a moment. I'm going to need a lot of room for this. Let me come down here, and let me put equals here. So the first thing is you would think about, what's my highest priority? Well, inside of here, do I have any parentheses? Well, I have these parentheses, but they're just used to wrap a number. So really I don't. I could just move on to exponents. And here I have this exponent operation. But again, if you're keying this into your calculator, this right here is going to give you -4. This right here is going to give you +4. Again, this is the negative of 2 squared, so your calculator is doing -1 times 2 squared, which is giving it -4. This one, it would do -2 times -2, which would give it +4. So I've got to make sure that I use the right one if I want the right answer. So this right here would give me a -4, not a +4 because it's not wrapped. Then times. Here you have this -15, and then +4, and then divided by 2. Let me close that down. And now I'm thinking about, okay, I have multiplication, addition, and division. Multiplication and division are on the same priority level. They are worked left to right. So this one is to the left of this one. So I'm going to multiply first. So -4 times -15, negative times negative is positive, 4 times 15 is 60. So this right here, I'll put the absolute value of 60, then +4, and then divided by 2. So now I have addition and division. You want to divide first. So 4 divided by 2 is 2. So we'll say this is the absolute value of 60 plus 2. And then from here, 60 plus 2 is 62. So this would be the absolute value of 62. We can go ahead and do that operation now. The absolute value of a positive number is just the number. So the absolute value of 62 is 62. And I'm just going to come back up here and put equals. I'm going to copy this. So the square root of 64, then times -9, then minus a -3. And the result of this was 62. So now I'm just going to put plus 62. I'm just going to keep working. Then I have minus. This guy right here is not going to fit on this line. So let me slide down just a little bit. And I'm going to write inside of parentheses, you have this -2 being squared. Notice that this is wrapped. Okay, that's very important. Then plus -8 and then divided by 2. And then this guy is squared. Okay, let's put equals here. In terms of what to do next, you have these parentheses here that you need to work inside. So I'm going to think about, let me just write this down here. I'll just put a little border. And I'll say that we have this -2. Again, this is wrapped, being squared. Plus you have -8 and then divided by 2. And then we're going to square this. I'm just working on this part right now. So thinking about my order of operations inside, I have parentheses, but they're just used to wrap this number and this number. So I move on to exponent operations. So I have that here, right? So -2 being squared. So again, -2 being squared, because this is wrapped, you're going to get 4. If you don't wrap it, if you key it in your calculator like this, you're going to get -4. So again, we have to make sure that we're paying attention to which form we're using. So this right here would be a +4, and then plus a -8, and then divided by 2, and this whole thing is squared. All right, so now I have addition and division. I want to divide first. So -8 divided by 2 would be -4. This would end up giving me 4 plus a -4. Of course, you could write that as 4 minus 4 if you wanted to, and this would be squared. So 4 plus a -4, those guys are opposites or additive inverses, or however you want to think about that. The sum is going to be 0. So we'll say this is 0 squared. Let me get rid of all this, and let me come back up and get rid of this border. I'm just going to copy things again. So I have the square root of 64 times this -9, then minus this -3, then plus 62, and then minus, this is going to be 0 squared. Okay, so I've dealt with all the parentheses and the grouping symbols. So now I want to move on to exponents. Now, this right here is worked on the same priority level as an exponent, because the square root of 64, as we're going to learn later on, is the same thing as 64 to the 1/2 power. We won't talk about that for now. We'll talk about it much later on, but you just need to know that if you're seeing some type of square root or cube root or something like that in an order of operations problem, it's going to be with the exponents in terms of the priority level. Okay, let me get rid of this. And first, let's do the one we know. We know that 0 squared would be 0. So let me write the square root of 64 times -9 minus a -3, then plus 62. And you can write minus 0 if you want, or you can leave it off. Of course, if we subtract away 0, it's not going to do anything. So let's just leave it off. Okay, let me slide down here. And now let's think about the square root of 64. So at this point, we have not talked about square roots. And basically, all you need to think about is this. If I have the square root of some number, let's just say 4, then basically what I'm asking for is what number, when multiplied by itself, will give me this number under the square root symbol, which is called the radicand. In this case, for 4, you would immediately think about 2, right? 2 times 2 is 4. So the square root of 4 is 2. Now, some of you are going to say, well, hey, -2 times -2 is also 4. So we have a different notation for that. You have the negative of the square root of 4, which would be -2. So if I ask what positive number, when multiplied by itself, gives me 4, I want this notation here. So this is the principal, or some people say the positive square root of 4, that is positive 2. Then this one, I'm asking for what negative number, when multiplied by itself, gives me the radicand, right? So this is the negative of the square root of 4, and that's going to be -2, because -2 times -2 would be 4. Okay, so we understand that general concept. And so with that being said, we would say, well, what is the square root of 64? Well, what number, when you multiply it by itself, would give you 64? Now, you could factor the number, which we haven't talked about yet. Basically, right now, I think most of you know that that would be 8, because 8 times 8 is 64. Again, if you had the negative of the square root of 64, that's where you would get -8. Okay, we're asked for the principal square root of 64, which is positive 8. So that's the difference between the two. So let me get rid of this. Let me put equals. Let me put 8 times -9, and then minus a -3, and then plus 62. So I don't have any exponents anymore. I just have multiplication, subtraction, and addition. So I want to multiply before I do any subtraction or addition. So this is positive times negative, which is negative, and then 8 times 9 is 72. So this is -72. Now you have minus a -3, and then plus 62. So we have talked about the fact that minus a negative is plus a positive. So I know this is one that trips up a lot of students, but when you see minus a negative, it is plus a positive. So I'm going to rewrite this as -72 plus 3 plus 62. Again, minus a negative plus a positive. So then if you want to, since this is all addition now, you can reorder it. I'm just going to say this is 3 plus 62 and then plus -72. Again, that's my commutative property to where I can add in any order. Let me actually grab this. Let me paste this in here so we have some room. So now I'm just going to add 3 and 62 together. 3 plus 62 is 65. So you get 65 plus a -72. So at this point, you basically have to think about, okay, I'm adding these integers with different signs. Which number has the larger absolute value? The absolute value of 65 is 65. The absolute value of -72 is 72. So -72 has a larger absolute value. So we're going to use that sign in the answer. So this would be negative. Once you're done with that, just work with the numbers as if they were positive, and you're just going to do a subtraction of the larger minus the smaller. So I'm going to go 72 minus 65. Borrow here, this is a 6, this is a 12. 12 minus 5 is 7. 6 minus 6 is 0. So I'm just basically going to drag that 7 up here and say that -7 is my final answer. Now, if you didn't get -7, go back and just be very careful and check your work, okay? If you're using an online calculator to check or something like that, just make sure you're wrapping things correctly. A lot of times, the smallest error will give you a big change in the result, okay? So the answer you're looking for here is -7. All right, let's take a look at a tedious problem. So for this one, before we get started, I need to explain something about fractions. So at this point in the course, we have not talked about fractions, but we're going to get to that topic very shortly. If I had something like, let's say 20 divided by 5, I could actually write this division problem using a fraction. So I can take my dividend, or the starting amount, and put that up here in the top part of the fraction, which is called the numerator. And then I'm going to have my fraction bar. And then this divisor here, this 5, I'm going to put that in the bottom part of the fraction. This is called the denominator. So I can say this is 20 divided by 5, or 20 over 5, or 20/5. There's a lot of different ways you could say that. But either way, this is going to be a result of 4. And we'll cover this in more detail later on in the course. I just want you to understand that you can write a division using a fraction bar. So when you come across an order of operations problem with a fraction like this involved, you want to simplify the numerator and denominator separately, and then you will perform the main division. So at the end, I would perform the final value in the numerator divided by the final value in the denominator, just like we did 20 over 5 like that, and we got 4. So we're going to do something similar here. Okay, so what I'm going to do is start off with my numerator and just simplify that. So I'm just going to copy it. So negative 2 to the 5th power divided by 4, and then times, we have this negative 3, and then plus, so we had these parentheses like this. I'm just going to use a different color for clarity. And then we have this negative 3 being cubed, and then plus the absolute value of 4 minus 4 squared. Let me close that down, and let me change back to this color and close that down. Okay, I'm going to grab this. All right, let's paste this in. We're going to go real slow, just step by step. So the first thing is we're thinking about, do I have any parentheses or grouping symbols? Don't worry about the parentheses that are used to just wrap a number. So this and this, you can ignore that for now. You're just thinking about, do I have any parentheses with some operations inside that I need to do? Well, yeah, I have these parentheses here. So I want to start inside of there. But once I get inside, I need to reapply the order of operations. So I need to think about inside of here, are there any parentheses or grouping symbols? And the answer to that is yes. So if I come in here, I see that I have the absolute value bars there. And so those are grouping symbols. So I would want to start with this right here. So what is the absolute value of 4 minus 4 squared? Well, inside of there, you would think about, okay, I have subtraction and then I have an exponent. So I want to do the exponent first. So 4 squared is 4 times 4, that's 16. So this is the absolute value of 4 minus 16. So a lot of you can do that in your head at this point. So 4 minus 16 is negative 12. If you can't, you can rewrite this as 4 plus a negative 16. Okay, so that is what you can do if you're struggling with things like that. You can always change it into a related addition statement, and then you can just use your rules for adding integers with different signs. So what I would say is the absolute value of what? The absolute value of 4 is 4, and the absolute value of negative 16 is 16. So the larger absolute value comes from this guy right here, the negative 16. So you use that sign in the answer. So I know this is going to be negative. Then you would do a subtraction, the larger absolute value minus the smaller. So 16 minus 4 would be 12. So this is negative 12. And we want the absolute value of that, which is going to be positive 12. So let me get rid of all of this, just scratch work. And I think because this is going to take such a long time, that maybe I could just erase things. I'm just going to erase this. And hopefully you've copied that down. And I'm just going to put a positive 12 there. So we'll just erase things as we go. So now I'm still inside of these parentheses here. And now I have an exponent operation and I have addition. So the exponent comes first. You have negative 3 that is being cubed here. So this is negative 3 times negative 3 times negative 3. So it doesn't really matter that this is wrapped here. You have an odd exponent, so you have an odd number of negative factors. That's going to give you a negative, right? Negative times negative times negative will give you a negative. And then 3 times 3 is 9. 9 times 3 is 27. So this is negative 27. Okay, let me get rid of this and put in a negative 27 there. Okay, let me get rid of this. Now, again, we're adding two integers with different signs. So you want to use the sign of the number with the larger absolute value. The absolute value of negative 27 is 27. The absolute value of 12 is 12. So negative 27 has a larger absolute value. So if I'm doing negative 27 plus 12, I know the answer is negative. And then I just do a subtraction. Larger absolute value minus the smaller. Let me put this off to the side. So you're going to go 27 minus 12. 7 minus 2 is 5. 2 minus 1 is 1. So I would drag this over here, and then basically you would have negative 15 as the answer. So let me erase this, and this is now negative 15. Okay. Let me get rid of this. Now, these parentheses, you could keep them if you want. They're wrapping the negative. You could drop them. It's really up to you. It's just personal preference. All right, so now that we've gotten rid of all the grouping symbols, we need to think about the exponent operations, and we have negative 2 to the 5th power. So negative 2 to the 5th power. Now, this is an odd exponent, so it really doesn't matter. If you typed negative 2 like this to the 5th power into your calculator, you're going to get negative 32. And if you wrap it, you're going to get negative 32. And that's because you have an odd exponent. So with an odd exponent, then basically you're going to have an odd number of negative factors, which gives you a negative result. Here, this is basically always going to be negative. It's the negative of 2 to the 5th power. So your calculator treats this as negative 1 times 2 to the 5th power, which is negative 32. With this one, it's saying, well, what is negative 2 times negative 2 times negative 2 times negative 2 and then times negative 2? Well, that's going to be negative 32. So just two different ways to think about things. The answer is the same either way, but how you go about getting it is different. All right, let me get rid of this, and I'm going to replace this with a negative 32. So negative 32. And so now we have division, multiplication, and addition. And this really looks like an X. I'm trying to make this a little bit more clear there that that's a multiplication symbol. So you have this division here that's going to occur to the left of the multiplication. And again, this is where everyone gets tripped up. Because of the ordering of the letters in PEMDAS, everyone thinks that multiplication comes before division. They have the same priority level. They are worked left to right. So because the division occurs to the left of the multiplication, you want to divide first. So you want to say, what is negative 32 divided by 4? Negative divided by positive is negative. 32 divided by 4 is 8. So this is negative 8. So I'm just going to erase this and put in a negative 8 there. Okay, so now we have multiplication and addition. So we have negative 8 times negative 3 that would be done first. Multiplication is the higher priority. Negative times negative is positive. 8 times 3 is 24. So this will just be 24. And for the last guy here, we're basically adding these integers with different signs. So again, use the sign of the number with the larger absolute value. The absolute value of 24 is 24. The absolute value of negative 15 is 15. So we're going to use a positive here because this guy has a larger absolute value. So I know this is a positive. So then I would just subtract. What is 24 minus 15? A lot of you can do that in your head. You know it's going to be 9. But again, you can always do it off to the side. What is 24 minus 15? You'd borrow here. This is going to be a 1. This is 14. 14 minus 5, that's going to give you 9. Okay, let me get rid of this, and you don't need that plus symbol there. So basically, I'm going to come back up, and the result of the numerator is going to be 9. Then this is over. I'm just going to copy the denominator. So we have this negative of 4 squared minus the square root of 9. And then plus, you have the absolute value of 2 times this negative 3, and then plus 18 divided by 3 minus 15. Let me close down the absolute value bars there. Then plus, you have this negative 1 being squared. Okay, I'm going to grab this, paste that in there. All right, so a lot to do here. You have these grouping symbols here, so for parentheses, and then you also have the absolute value bars there. So I'm just going to start with this one, and then we'll simplify this completely, and then we'll work on this one, and then we'll see what else we have. So inside the parentheses, you have the negative of 4 squared minus the square root of 9. So what is done first? Well, in this particular case, you have an exponent operation, and then you have a square root here. I told you those are the same priority level. So it really doesn't matter if I do this one first or this one first. I'm going to basically do each one of these operations before I do this subtraction. So if I think about, again, the negative of 4 squared, have to be careful there. Your computer or your calculator, whatever you're using, is saying this is negative 1 times 4 squared. So this is negative 16. Again, if you want positive 16, you have to wrap that. So you would have to do negative 4 wrapped in parentheses being squared, and that's going to give you 16. And I know I keep going over this again and again and again, and that's just because it comes up all the time as a common mistake. So let me get rid of this, and let me replace this with negative 16 here. And then the square root of 9, again, we are asking for what positive number, when multiplied by itself, gives you 9. Well, that's going to be 3, right? So I'm going to say that the square root of 9, or at least the principal square root of 9, is going to be 3. So now I have negative 16 minus 3. And so you can go plus negative here to make that a little bit cleaner. And let me wrap that. So we have the same sign here. So I'm just going to put a negative there and then just add the absolute values. So 16 plus 3 would be 19. So this is going to be negative 19 as the answer. Okay, let me get rid of this. And actually, I'm just going to erase things as I go. And I'll just say that this is negative 19. All right, so now I'm going to mess with this guy right here. So inside the absolute value bars, you will notice that you have what? You have multiplication, you have addition, you have division, and subtraction. So the multiplication occurs to the left of the division. So that means it has a higher priority. So I'm going to go 2 times negative 3 first. A negative times a positive or a positive times a negative will give you a negative. And then 2 times 3 is 6. So let's get rid of this and just put negative 6 there. Then I have addition, division, and subtraction. So you want to divide first. 18 divided by 3 is 6. So let's put a 6 there. And so now I have addition and then subtraction. So the addition and the subtraction have the same priority level. We're just going to work them left to right. So here we're seeing that the addition occurs to the left of the subtraction. You want to add before you subtract. So you have negative 6 plus 6. So I'm adding a number and its opposite or a number and its additive inverse. That's always going to give me 0. So this right here is 0. So you could write 0 if you want, or you could leave it off. It really doesn't matter. 0 minus 15 is still negative 15. So I'm just going to put negative 15 there. And if I take the absolute value, let me close this down so this is a little bit more clean. If I take the absolute value of negative 15, that's going to give me positive 15. Okay, the last thing here, let me move this down. The last thing here when we're looking through everything, we have an addition, we have another addition, and then we have an exponent operation. So I want to perform the exponent operation first. So you have a -1. Again, this is wrapped and it's squared. So this is -1 times -1, which is 1. And again, I'll show this one more time. If you had written the negative of 1 squared, this becomes, in your calculator, -1 times 1 squared, which becomes -1, right? So -1 times 1 is -1. Let me get rid of this. And of course, that form there, because it was wrapped, that's +1. Okay, so now we could just go through and add. Again, I like to add the numbers with like signs first. That's possible because of the commutative property. We can add in any order. So I could say that this is 15 plus 1 plus a -19 like this. So 15 plus 1 is 16, and then you have 16 plus a -19. Now, a lot of you can eyeball this and see that it's -3. But again, you can always go through the official procedure. So I would use the sign of the number with the larger absolute value. The absolute value of 16 is 16. The absolute value of -19 is 19. And so -19 has a larger absolute value. So we're using its sign. So the result is negative. And then you just subtract the larger absolute value minus the smaller. So 19 minus 16 is 3. So this is going to be -3 as the answer. So let's go back up and let's put a -3 there. So at this point, again, you can convert this over. Remember, we said that 20 divided by 5 could be written as 20 over 5, which was 4. Well, if I have 9 over -3, I can convert that over, if it's easier for you, to 9 divided by -3. So either way, I'm just going to keep it like this as a fraction. But if you need to do that for right now because you're not used to working with fractions, that's fine. Basically, 9 divided by -3, a positive divided by a negative, or a positive over a negative, that's going to be a negative. And then 9 divided by 3 is 3. So the final answer here is going to be -3. Now, this problem has so many different operations that if you didn't get -3, you really have to go back. A lot of times, problems like this, you just rip the paper up because there's just so many places you can go wrong. But you really want to go back and just check every step, and you can follow along with the video to see, well, what answer did I get for each step? And then, as I said before, the smallest mistake on a problem like this can give you a really, really different answer. Okay, so you're looking for -3 as the final answer.